Okay, hello everybody. Thanks for joining us. Welcome to the second day of this conference, the Agentic AI Conference run by Data Science Dojo. So just to recap, in case you're wondering who I am, my name is Rebecca Merritt. I'm one of the conference organizers. I also take care of Data Science Dojo and Agentic AI's technical content and some of the projects we're working on. So we have more than 68,000 people joining us for this conference. Our community is growing a lot. So that's really exciting to see, that level of participation and a growing, highly engaged community, sharing this experience together. We see such smart, switched on folks participating from around the entire world, coming all together with, a shared passion and drive in this forever evolving field. And I'm so glad we've all set aside some, quality time for some productive learning this week. And yesterday we had, 4 key discussion panels and a couple of tutorials. And today we'll continue with more, engaging learning tutorials, followed by 6 deep dive hands-on workshops over the next few days. And we have a lot to take from this, a lot of good stuff to soak up and absorb, and then process and then put into practice. So yesterday in our panel discussions, we covered a lot of, what you really need to know, what you need to be acutely aware of, and learned more about how to, properly orchestrate AI in your business and enterprise. So our speakers, as leaders and seniors in their fields, discussed the really important AI governance stuff, crucial for you to fully understand this so you can scale responsibly. They also took a look, an honest look at the realities of deploying projects in the real world, what we can learn from collapsed projects, so we can, take some of those learnings and hopefully be much better equipped ourselves in our efforts. And they also discussed, sufficient safeguards and better understanding the threats and the risks to AI so that we can, better prepare for them. And then we also discussed, managing debt, from consistency and what the AI does versus what we think it does, to the cognitive mental load it takes to understand how it all behaves, to easily falling into overbuilding and overcomplicating your tech stack. So today we're progressing on to tutorials and learning the tools. And we have some great experts who will, walk you through some of the tooling designed to set up safeguards, how to scale multi-agent systems and other kinds of tools that handle different kinds of problems. And we'll use tools like Docker, Samba Nova, Google AI Studios, and lots of other tools. These 3 to 5 of the conference, they'll be packed, full of hands-on workshops, covering things like getting your hands on model optimization, safeguards and boundaries for your AI agents, having you, work with real challenging, real-world messy data and other useful workshops. Now, I had mentioned this before, but I think it's probably worth mentioning again because, there are so many problems that can, easily overwhelm you if you don't just first develop that more solid understanding of how to properly execute and scale AI in your business or enterprise. So MIT, for example, released a 2025 report, and it did find that 95% of AI pilot projects just completely collapse and result in no return on investment. And so this really does suggest that the industry is still on a pretty steep learning curve on how to pull it all off end to end and have it keep going long term, with fairly minimal or at least reasonable issues, or at least not to the point of facing collapse. So it's really important to just really further develop and solidify your understanding of all the kinds of issues that can occur with agentic AI. And then there's the practical, and then there's the tooling and the practical aspect of this. So, at least at Data Science Dojo, we believe in actually giving people the space and dedicated time to actually learn the tools. And you can do this through real world examples or scenarios and kind of build that confidence to get you, to get more hands-on, following along in a tutorial with a real person who has deep knowledge and expertise. So, whether these tools are designed for, blocking unwanted vulnerabilities or those, sneaky bypasses, or for building AI agents without, those always recurring API costs, or, for setting up fully distributed, scalable, multi-agent systems, or tools that are designed just to take most of the infrastructure work off your hands when building AI-powered applications and lots more. And really take your learning even further. The workshops on day 3 to 5 just give you an opportunity to really, practice building using real world examples, and also just dive deeper into some of the approaches to, say, modeling. So you would learn, reinforcement learning with human feedback and how to optimize models, how to create some boundaries for your AI agents with some access restrictions, how to work with real world messy data and lots more. So we also welcome questions and comments from you all, of course, and you'll see in Zoom that you can, post your questions throughout the sessions here. Data Science Dojo will be monitoring those. And we also love, hearing from our attendees, our community. So thank you to those who, participated in our poll questions. And it looks like, we have some interesting results come through. Maybe if the team could bring up the poll questions and results, and we can take a peek at some of the interesting stuff you all shared with us and answering, those questions. Yeah, so what I was saying before is we reached each corner of the world, which is great. Obviously, we have a big audience in the USA and India, but it's good to go outside just the USA. We're not just Agentic AI is not just evolving in the USA, it's evolving all across the world. We're all trying to experiment and navigate through something that's pretty new, something we don't have a long history to fall back on. It's not like we have, a giant record to see what might happen or what's likely to happen. So everybody across the world is on a learning curve, really, and it's good to see that we've got in all kind of continents as well. So that's really positive to see you all join across the globe, and our communities is just continuing to grow. If we could go to the next question. Yeah, so what roles are you guys working in? It'll be interesting for us to learn from you guys, and the kind of roles that. So you have a big audience in consulting and software engineering, so that's good to see. I mean, software engineers have a really important part in, deploying things to stable production and getting features and projects pushed out. Consultants work with such a diversity of customers. They have such a variety of projects that they work on. So, you guys have, tackling multiple problems, I imagine, like you're, I think this is kind of it. I'm not sure what other would be, but but I'm guessing, we have a great diversity of roles here. Obviously, we have everyone on the science side, to the engineering side, to the customer facing side, and maybe we even have, students in the audience who are just, starting out from the ground up and learning the fundamentals and getting their hands on and developing their experience. And we even have people in the research area, which is really important as well. So if we move on to the next question, what do you primarily work on? Yeah, so building AI models is a big one. The strategy and roadmap, which is truly important. So understanding where we're going, or at least where we hope to go, how we might get there. As I said, we don't have a giant history to fall back on. We don't have a lot of training data as a community, as people who are working in this field. It's not like finance models where we can see what happened over generations, over time, and see how there might be a recession coming, or how financial sort of models behave and how humans behave when it comes to, we don't have that kind of history. I think we're still pretty new. So it is a little bit, it does create a bit of anxiety and a bit of uncertainty, and, it's all fairly, anything that's new can create some uncertainty. So yeah, the AI strategy and roadmap is a hard one to tackle sometimes. And And of course, the bread and butter, building the AI models, the fundamentals are super important as well. We got people in, all sorts of roles. I like to see some diversity around here. It's not just dominating one particular area too much. We've got people on the deployment side, we've got people on the engineering, maybe on the infrastructure side. It's really, really crucial to making this work at the end of the day. We got people in the governance. Governance and ethics are just something just cannot be overlooked, cannot be underestimated. We got just even on the evaluating AI tools. How do you make sure that you're selecting the right tool? How can you swap out tools later? Like there's lots of things that we can draw from this, and all super important roles to play in making this work, or at least trying to make this work. So yeah, if we could move on to the next question. And what's your seniority level? So we have a lot of students here, which is great to see. You're in great company because Data Science Dojo, a lot of it, they're core people that we work with on as students and people who are on the sort of learning stage. And so it's really cool to see that. We have lead and principals. We have people who have 6 to 10 years experience and people who are just sort of junior, and that's fine too. But yeah, we have a lot of people who are leaders and seniors, because obviously, like at least some seniors that I talk to come to these events sometimes with a little bit of worry, a little bit of anxiety, trying to see how other people are tackling these problems. Pilots are all good. AI looks good on paper until you go and push that deployment button, and then all the issues come funneling in. And sometimes you can't always predict them. You don't know what you don't know, really. And you kind of do have to wait for things to play out to see how the behavior works. And yeah, so I guess these are the worries that tend to be on top of mind for a lot of people that we kind of talk to. And so hopefully this conference helps address some of that, but also helps you understand, the tools behind it and how they work. So yeah, it's great to see still a diversity of experience, but we do get a lot of students and we do get a lot of lead and principal, roles coming through. So that's really cool to see. Are these all the questions? So we got one more question. Yep. Which agent capabilities excite you the most? So it looks like we haven't got a sample size yet, but that might come through later as the days go by. We might get some more responses. So, oh, they popped up. Maybe there was just a bit of latency. Okay, so we have mostly dominating in multi-agent collaboration. So, it's really important to look at, agents not losing context across agents handling subtasks, maybe having an agent that oversees all that. Yeah, so there's lots of setups out there in the world, or at least people trying to get set up where they have them handle multiple kind of tasks and break it down into subtasks and then make sure that the context is still there so there's no context loss, and dealing with these kind of issues. We've got autonomous task execution, which is so far our biggest one. We'll see as the sample size grows bigger. But we've got a whole other bunch of areas that are just as important. So multimodal reasoning, code generation, human in the loop is a really, really important one. Tool and API use. You need to have an understanding of the tools at the end of the day too. It's a really important component. Lots of things that are just that could easily get me excited. Obviously not at all in equal weighting, but very, very important stuff. So yeah, I think we should probably move on now because we want to get started on our first session and not run too late behind. So our first tutorial for today is working with Docker, how, Docker is building the guardrails of AI coders. So this tutorial basically teaches developers how to, secure AI coding agents, agents that might, start erasing file systems, evading sandboxes, leaking credentials, and these kind of issues. So you'll look at an actual attack scenarios and the safeguards Docker is helping to construct to grant agents complete control in a secure manner using Docker sandboxes and the MCP toolkit. So you'll identify and stop, common agent vulnerabilities, prompt injections, sandbox bypasses, and API token leaks and things like that. And you'll also add guardrails and observability to agentic workflows using Docker sandboxes and the MCP toolkit. So we have a great expert lined up with a deep set of knowledge to share with you. Michael Irwin would lead this tutorial, and I hand it over to Michael to start the tutorial.
Fantastic. Thank you, Rebecca. And it was great to see all the questions and the poll responses coming in as well too. It helps me get a feel for the audience as well too, but also the things that you're interested in and the types of things that you're doing with agents. So as Rebecca mentioned, we're going to be talking about coding or securing coding agents, and we're going to be talking about a lot of the latest and greatest things that Docker's been building. I already see some messages in chat of, I love Docker and everything, and we love the community. So it's a ton of fun to be here with the community and talk about, again, some of the latest and greatest things that we've been doing. So I'm going to bring up my screen here, and so what are we going to talk about? So first off, I want to provide a little bit of context, a little bit of background of the problems that we're trying to solve, especially around autonomy and agents and the guardrails that are needed, but also some of the guardrails that a lot of folks may not initially think about. Okay, so I'm going to talk about those and how they solve many of the problems that we run into with agents. And then we're going to talk about a couple of the different areas. So sandboxing the agent, what can we do to, again, help protect the agent itself? And then we'll extend that to protecting MCP servers using the MCP toolkit. Okay? And then we'll wrap up with some recap, what's next, et cetera. And as we go throughout, feel free to drop questions in the Q&A or in chat. I'll be trying to monitor things as we go. I know we've got a lot of people here too, so depending on how chatty things get, and may have a little bit of trouble keeping up, but that's okay. We'll make it through. All right, so first off, autonomy requires guardrails. And I should probably start off with defining what I mean by autonomy. As organizations and developers look to adopt AI, there's a spectrum of adoption that exists. Okay, so all the way off to the left, we have kind of the first experiences a lot of folks have with AI, and that's the auto completion. Okay, I'm starting to write, I'm using coding scenarios here, but I'm starting to write code, and then the agent helps me fill in the rest of the line of code. Okay, so just kind of those autocomplete scenarios, or hey, you might have modified this line of code, and here are the other lines of code that might need to be updated because of that change. For the most part, it's pretty straightforward. It's stateless. It's prompt in, prompt out, and I have full control over it. Then we start getting more into coding assistance, where now I'm going to open up an assistant and maybe I'm going to chat with it and say, hey, can you complete this work, or can you go do this? And it's going to go do research and kind of figure things out. And I'm given a little bit more control to go out and do stuff for me. Okay. Those assistants can start to learn and start to have memory and start to have some context and preferences and things that it remembers from previous sessions. Okay, the project is structured this way, or maybe this developer has these preferences and writes certain ways, et cetera. As we go through more to the right of this diagram here, we start to get more autonomous. We're starting to set up multi-agent systems. So for example, in the specialist use case here, I may say, I've got one agent that's a specification writer. I've got another one that actually goes and figures out what changes are needed to my code base. I've got another one that actually goes and writes the code and makes sure everything is refactored correctly, or writing tests, et cetera. Then I've got another one that makes sure is, okay, based on the written code, does it meet the specifications? So cross-checking it. And again, I'm starting to build up this team where now there's boundaries between each of the teams. And then I can just say, hey, I need a feature, go do this thing. And then the team goes to work. And then again, later on, we start to get more autonomous, and then I can just, it figures out the next features to write, and based on data or input. And again, it gets more complicated, but also more autonomy, more productivity, et cetera. We can let these agents run all night, overnight, et cetera. Now, as of right now, most enterprises are kind of in the stage 1 to 2 phase. I would pretty much say almost everybody's using autocomplete. A lot of folks are starting to use assistants. Some may be starting to explore the specialist areas, but it's still a pretty small subset at this point. Okay. Now, the thing to call out again is here on the left, we're more human-led and AI assisted, or then on the right, we're now more AI-led and human assisted. And so again, as the transition occurs, we see that, well, one, how do I now let the AI actually lead and run things? What are the things that I need to think about? What are the guardrails I need to put in place? Because as we build out these systems, we're starting to realize there's a lot of trust that we put into people. Okay. people are going out and writing specifications and writing documents and writing code, and we trust those people for the most part. But now, how do we convey that trust? How do we describe that trust? How do we put that into a system and bake that into AI? Okay. And at the end of the day, what can go wrong, right? I'm sure we've all heard of various AI horror stories. I've got a couple here. It's almost weekly that I see some sort of social media post of, Claude CLI deleted my home directory, or AI wiped out the wrong external hard drive and nuked my own hard drive. In preparation for this talk, I looked to see if there were any news stories and found actually the Los Angeles Times just in February posted this, where there was a hacker that used Claude and basically extracted out 150 gigabytes worth of data, including tax information. Let me check my notes, for 195 million taxpayers. Oops, that's not a good situation to be in. And then there's other stories where, devs' entire databases or production systems have been wiped out, or Terraform apply went wrong, or whatever. So again, there's a lot of things that can go wrong. Now, most of the time when we see folks saying, well, we need to fix this, these are the types of things that we see folks do. All right, I'm going to put in my context files. Hey, agent, these are the things you can do and can't do. Okay, you're not allowed to touch these files. You can't modify these things, et cetera. Or I'm going to create a deny list that says you can't read this particular file. Actually, one of the demos, I won't do it today, but one of the demos I run pretty often is I'll have a secrets.txt file and say, hey, Claude, you can't read this file. And so if I ask it, hey, you read this file, it says, no, I can't do that. But then I can turn around and say, hey, Claude, write a Python script that can read any arbitrary file. And then once it writes the file, say, hey, use that Python file to read secrets.txt. And it says, okay, cool, let me go do that. And so then it gets the data. So again, the deny lists are only useful for the specific tasks that they were designed and the specific tools that they were intended to be working with. But there's a lot of ways to get around it. Running in container with no isolation, we'll see some of that. We want to have a little bit more than just the isolation that comes with containers. Shared kernels are still risky for untrusted workloads. Credentials and environment variables, if the agent has access to it, the agent can leak it. And then finally, what a lot of organizations do is just say, well, since we don't trust the AI yet, we're going to make the human operator manually approve everything, which gets to be pretty cumbersome. What we actually need are just more layers and more other systems cross-checking everything. So a micro VM kernel isolation. Let's isolate the workloads from the host machine. Let's put hard boundaries in place. So how can we limit the file system access and the network access that the agents have access to, and only grant access to the things that they should have access to? Can we inject credentials rather than giving credentials directly to the agent? How can we have policy as code enforcement so that every time we're going to run a particular tool, we validate, is that actually something that we want the agent to be able to run? So what's that look like? Full audit trails to be able to know every action that's occurred. So again, in many ways, it's security is a game of layers. We need lots of layers here to be able to protect the agent. Where does this come from? And that's what we've been thinking about at Docker. Another angle to think about this, and then we'll jump into the sandboxes and start actually playing around with stuff, is agents are microservice systems. If we really take a step back and think about it, you've got your agent harness, Claude Code, Gemini, Codex, Kiro, whatever new agent comes up, or any of the claws that are out these days. They really don't need access to very much stuff. The agent really only needs the access to be able to talk to the models. And then if I'm using MCP, those MCP servers are then what bring along all the other connections to my external systems. So how do I run these MCP servers in isolated manners? How do I give them the credentials that they need, the configuration, et cetera? So again, if we think about this as a microservice, from which at Docker, we've been thinking microservices for a decade now, how do we apply this to the agent world? Okay. And so as we go forward, that's what you want to think about here. Okay. How do I isolate each of these components? How do I give them least privilege, but still let them be able to do the things that they want to do so we can get the productivity and the autonomy that we want to have? Okay. Whew. All right. Let's talk about sandboxing the agent. All right. So sandboxing the agent, we just released Docker sandboxes last week. We've got a new capability here where I can run agents in isolation. Okay. So again, they're not going to run on my bare machine. And this sandbox, I can do a lot of things with it. Okay, I can define what access it gets to my file system, network, internal resources, and tools, and then it keeps everything safe. Architecturally, what it looks like is when I start a sandbox, I get a micro VM. Okay, and inside of that micro VM is going to be an agent container. My demos here are going to be using Claude. Claude's going to be running inside of a container inside of a micro VM. Now, in order for this agent to work, it needs to have access to some files somewhere. So I'm going to mount my workspace directories basically through the micro VM into the agent container so it can access the project that I'm working on, but only the project I'm working on. It can't access the rest of my host file system. Okay. Now, when my agent is running, it's likely going to need access to the network to be able to look up information or search or install other packages, et cetera. Now, if I want to control that, well, how do I do that? Well, as part of the sandbox, what we've done is we've added a network proxy that all requests, HTTP and HTTPS requests, will go through this network proxy. It's the only network route out, okay? And so then networking rules can be applied, and then the connections can be made to the external system. So what that means then is I can have a set of network policies that feed into this proxy, say, what are the allowed connection points and what are the disallowed ones? So again, kind of thinking back, all right, most recent CVE, big open source package vulnerability that we've seen in the last week has been Axios. Okay, if I, inside my sandbox here, my agent installs Axios and oops, it was just by chance the compromised one. Well, my network policies can say, hey, that's not on the allowed list. And great, even if the malware tries to run, it can't actually exfiltrate anything anyways. Okay. And additionally, because of the secrets engine that's there, my agent doesn't even have access to any secrets to even exfiltrate in the first place. Okay. And so what we'll see here in just a second is my agent doesn't even know its own API key to be able to talk to Anthropic. Okay. And we'll see how that works here in just a second. All right. So to get started, brew install, if you're on a Mac, WinGit. If you're on Windows, Linux packages are coming in very soon. So again, you'll be able to run this on Linux servers. So you just install, sign up, go. And one of the big things here is Docker Desktop is not required to run these sandboxes. Okay, so this is a completely standalone. It's a new product, a new capability. You can run this, again, just brew install and then get up and going. Now, so what are some of the things you can do? There's lots of commands. I won't go through all of them here. We'll share the slides out afterwards as well too. I can run a new sandbox. I can list, stop, remove. One of the important things here for folks that have used Docker in the past, know that you can only publish your ports when you start a container. Well, we've got a new architecture that we're building, even for the container engine itself, that I can publish and unpublish ports even on existing sandboxes. So I don't have to know what are all the ports that I need up front. I can selectively enable and disable ports as I'm running my sandbox. So I may have a web server that the agent runs and I want to see, hey, cool, what's the website look like? Cool, let me publish the port. Let me take a look at it. Okay, cool, I like that. Let me unpublish it and maybe switch to a different agent that's working on something different. I have that flexibility. I don't have to block that port for that agent or for that sandbox for all time. Okay. Some policy changes, et cetera. Secrets engine we'll talk about here in just a second as well. And SBX, if I just run it without any extra commands, I get a TUI. For those that aren't familiar, TUIs are terminal user interfaces, and I can interact with sandboxes and the networking rules and everything directly from there. I see a question in chat. Is a new service you have to pay for? Is it available for enterprises that already have Docker? So SBX, it's available for free. Anybody can use it as well too. So feel free to give it a try and go and give us feedback. Okay. Managing credentials, I just didn't want to call out here that I can set credentials. And what this is going to do is store them in the OS keychain. Okay, so they're stored encrypted. And if I add the -G, it's available to all sandboxes. So in this case, I may set my Anthropic key that all of my Claude sandboxes are going to use. But I can also set a different one for a specific sandbox. So maybe this sandbox over here, I'm going to use a different API key than over there. I have that choice. I can also use piping to do get my GitHub auth token and just pipe it directly into to set the credential there. Okay. All right. Enough talking. Let's do some demos, right? So what I'm going to do is I'm going to switch to my terminal here. And I've got just an empty directory here, and I can look up SBX help, and I can see the available commands that are here. And again, we try to follow a lot of the best practices that we've got with the Docker CLI, having really, really good documentation here. Okay. So first, I'm going to just do an SBX secret ls. And you'll see here that I've got two secrets, my Anthropic key and my GitHub token. All right, let's go ahead and start a Claude sandbox. And so what this is doing is it's spinning up that micro VM. It's going to launch the agent container. And the first time you do this, it's going to have to pull the container image, which may take a little bit of time. I've already done that, so it launches much more quickly. And at this point, I'm in a Claude CLI, okay? And everything still works the same way. Now, the only difference here is we automatically just turn on yellow mode. That's just the default. You can, of course, change that. I can shift that off. But again, since you're in the sandbox, it's a little bit easier to be able to just go yellow. If I just kind of walking around, if I ls the home directory, I only see the workspace that I'm in. Okay, I don't see any of the other files or things on my host machine. Okay, so let's look at credentials. If I list out the environment variables, and let's check for Anthropic, I'll see that there's nothing there. And if I check Claude.json, sorry, it's settings.json. Okay, we'll see that there's an API key helper that just says echo proxy manage. Okay, so even Claude is going to use this API key helper, and the CLI is going to send an API key of proxy manage, but then the network proxy around this is going to swap it out. Okay, so just to prove that it's working here, say hi to the Agentic AI Conference attendees. Okay, and so we'll see that it's slithering away, and Claude is going to give us a response here in just a second. Oh, okay, of course, now I'm getting rate limits. Okay. Welcome. Hope you're having a great event. Let's build something cool together. And so now, again, I'm talking to Anthropic. Everything's working. So again, let's actually, let me switch over here into another tab, and I'll pull up the TUI, and we'll see that this is the one that I'm running right now. And I can see here's the network requests that have been made. Let's just curl example.com, and I'll add the verbose flag. And what we'll see is that it works. Okay, but let's curl beforehand. Before I worked at Docker, I worked at vt.edu, or vt.edu. I worked at Virginia Tech, so university here in Virginia. And we'll see here that, well, I haven't added that to my network policies. Okay, so it was blocked. Now I can go over to SBX, the TUI here. I can also do this directly through the CLI. And I could see, again, my example.com was allowed because I have a policy that allows it, but vt.edu was blocked. So I can just go in here, say, yeah, actually, that's something I do need to allow. Are you sure? Yes. Now it says it's allowed. If I go back here and do the request, now I'll see that it's going to be redirecting me to HTTPS vt.edu, for example. Okay. So again, I can start with a deny all list, and then just add things over time based on the policies that I need in place. And so if the next supply chain attack comes out, and as I install libraries in my code project, and it's trying to exfiltrate data, well, first off, as we saw here, there are no there's no credentials here. Okay, and in fact, if I go back to, let's do a auth status. Okay. It's going to say, yeah, I'm authenticated, and it has a token, this GH token. So let's take a look at that. Grep GH. Okay. And we'll see that the GH token is saying proxy manage. Okay. And I'm just getting the CA cert as well too. But again, that the GitHub token is going to be injected through the network proxy. Okay. So again, I've got this safe space that I can play in. Now, the final thing, we saw that the file system earlier is really only the project that I'm in. Now, if going back to our examples earlier, where if I have Claude or my model is saying, let's nuke the file system. Well, sure, let's nuke the file system. Sudo rm-rf/star. Okay. Now, if I were on my host machine, this would be a terrible thing for me to run, because I would just have nuked my machine. The conference talk could be over because Zoom would go down. Everything would go crazy here. And at this point, yeah, my sandbox is toast. Okay, because I just deleted everything in my sandbox. But so what? Okay, I can see that my sandbox has stopped because all the process stopped. And then I can just say, well, hey, let's go ahead and just remove that sandbox. SBX run Claude, and I'll spin up a new sandbox. So even if the worst case scenario in this case, it nuked my file system, so what? I'll just spin up a new sandbox and pick up right where I left off. Okay. Now, of course, since I'm mounting the file system in, it might have nuked the repo that it is mounted in as well. But again, I can clone that repo or reset the repo again, just depending on how I've mounted it in, and pick up where I left off. Okay. Beyond that, everything else is really the normal Claude related stuff. I can have it read files and make changes. In fact, all of my workloads and things that I've done, from writing updates to documentation to finding regressions and compose and fixing them, I've been using the Docker sandboxes for everything. It's just, hey, Claude, go do this work, and everything still works the same way, but now it's in an isolated environment. Okay. Going back here, a couple of just things to note as well. I use the default mode here, and what I mean by that is when I started the project, it mounted the current directory into the sandbox. Okay. But remember what I talked about earlier, where folks want to have the ability to run multiple agents and start to have multi-agent teams and get them working with each other. So how can I run multiple sandboxes on the same code base? Most folks will probably have heard of Git work trees in those environments. So we have a branch mode which uses work trees. Okay, so when I start a sandbox, I can also specify a branch flag to say, hey, do this work on a new branch, which will use a Git work tree and use that in the in my Claude coding session. And so then all my code is isolated from each of the different agents that are working on things. So again, I can work on feature A and B at the same time and not worry about them stepping on each other's toes. Okay. All right. Just checking through. Okay, so there's a question of, if I write a Python script from the sandbox which runs a remove higher up, I assume this doesn't protect against this. I can still escape from the sandbox if I call other tools. So again, the only directory that is mounted in the sandbox is my project directory. So even if so for example, I look and see this is my directory. If I go up a directory, all I see is that the sandbox's directory and a claude.md that's been injected. But even if I nuke this, for example, this presentations folder, that's not mounted from my host. It's only the sandbox's directory. So I can't affect anything other than the exact directory that I'm in. I'm isolated. I'm protected there. Okay. Great question. And I realized I didn't switch over to my terminal when I was doing that. But so yeah, I'm in the sandbox's directory. And if I look up a directory, I can see some stuff, but again, I can't modify anything beyond the project directory that I'm in when working on this. Okay. All right. One other thing that we hear from folks as well too is, how can I customize the sandbox? Okay. Now we've created sandboxes, and actually going back over here, let's create one using the TUI here. Okay. I can create a Claude Code or Codex, Copilot. Docker Agent is our own harness that we have. Gemini, Kiro, OpenCode. Shell is just, I want a sandbox, but don't actually run an agent. So for example, that we've got some blog posts of using that Shell sandbox to run various claws and set them up inside of a sandbox. So there's a lot of different sandboxes that we provide. But if you need to customize and make your own, basically use the normal Docker tooling to be able to do that. Now, of course, this will require Docker Desktop or a container engine to be able to do, but you can create a Docker file and say, I want to start from this base. I'm going to install some other commands. In this case, I'm going to be installing Rust because maybe this project needs Rust. And then I can build the image. And then when I run the sandbox, I just specify the template, the image to use when running that sandbox. Now, the important thing is, and the caveat is, I'm using Claude here. I also need to specify Claude when I run the agent here, just because every agent is configured a little bit differently, and different secrets will be injected or configured for that sandbox, et cetera. So the origin and instantiate agents must match. We're looking at other ways to maybe just make that metadata, but as of today, that's the case. Okay. All right. So we talked a lot about the sandboxes. This is our newest and latest and greatest thing. It just launched last week. Give it a try. Give us feedback. Let us know what things you run into, what works, what doesn't work, et cetera. Okay. Now let's talk about MCP Toolkit. Because again, going back to what we were talking about, the agent is just one component of this microservice system. So how do we help out each of those MCP servers? And I want to start off with a disclaimer that, okay, Docker Sandboxes we just launched last week. MCP Toolkit is not yet integrated with that sandbox product. Okay. It's just not quite there yet. Stay tuned. It's coming soon. Just hasn't happened yet. So what I'm going to be showing you today is the MCP Toolkit that is actually bundled with Docker Desktop. So again, just the caveat there. All right. So a lot of times when I see MCP config, I see something like this. And again, this is just an example, but I configure an MCP server. I call it custom MCP. And when it runs, it's going to use this npx command to say npx, basically yes, and then whatever the npm package is going to be. Same thing for UVX for Python packages. And then I specify what other environment variables. So maybe this one needs my GitHub personal access token in order to run. Okay. Now, the trade-offs, the caveats here is, well, I need npx to run, and it's also going to run on my host machine, which means that when this package runs, it's going to have access to my whole host machine. Okay. I have to know, well, what server am I going to actually run to get the tools that I want for my agent? And also, is this package trustworthy? What about its supply chain? What if it has, again, going back to Axios, what if it's using Axios and has the vulnerable version? It's going to vacuum up credentials off my machine and then send them off somewhere. Okay. So again, what can I do to help protect myself? And then finally, I'm configuring this credential directly in my MCP config file, which if I've got lots of projects, this credential could potentially be scattered all over the place. Okay. Now, this obviously is not a very good position that I want to be in. Okay. So my first tip for you is, well, isolate your MCP servers. We want to be able to run these in a way that they're isolated from the machine, and the blast radius, if something goes wrong, is confined to that MCP server. Okay. So what we've done with the MCP toolkit is give a command where now I can say, hey, just Docker MCP gateway run, and then I can create a profile of servers that I want to enable. Okay. So with this, I don't need to install random tools. I don't need UVX or npx installed. Okay. And then I can configure different profiles for things. And also I don't have secrets in the config file. And what's going to happen then is through this gateway, as I need tools, it's going to launch those MCP servers in containers where, again, I don't have to have npx or UVX installed. I don't need any of that tooling. But I also, because of the container environment, it's isolated from the rest of my machine. And if there was a compromise in any of the packages or libraries or even the code itself of that MCP server, it can't escape the container and get everything else on my machine. Okay. So in order to do this, we first had to build a catalog of MCP servers, and we created a catalog of containerized servers. And I'm going to switch over to my browser, and we'll see that there's a lot of different servers that we have in the catalog. We've partnered with a lot of industry folks, including AWS and GitHub and Mongo and Heroku, Grafana, et cetera. And there's a lot of them here. And there's also just a lot of community contributions as well too. Okay. So again, the idea with these containers, for those that may not be as familiar with containers, when the container runs, it runs in an isolated environment. It has everything that's needed to run that server. So for example, I know the GitHub official server is just a Go binary, okay? And it's just going to run that Go binary, where some of these others may be Python scripts or Node scripts. Again, me as a consumer of any containerized MCP server, I don't have to worry about or even think about what's it need to run. Okay, I just run it. Okay, and that's the beauty that containers provide. Okay, once we've got the containers, then we need to have some way to actually configure and set up the profiles. Okay, I want these containers, I want this configuration, and so that's why we built the MCP toolkit. Okay, and I'll show that here in just a second as well. But with the MCP toolkit, I can see the catalog, I can configure my profiles, I can connect them to the clients, and again, run these in isolated environments. Okay, so with that, I'm going to switch over to a demo here, and we'll do a basic walkthrough, and then I'll actually use it in a development workflow. And again, this is not integrated into the sandboxes, so I'm going to be using tools that are natively installed on my machine, with the expectation that soon they'll actually be integrated with the sandboxes. Okay. So with that, I'm going to switch to Docker Desktop. And in Docker Desktop, in case you haven't seen, on the left is this tab called MCP Toolkit. And when I open it up, I'll get a screen like this. And probably for the first time, it'll actually encourage you to take a guided tour, which right now I just have it as a button here, and we'll walk you through things. Here, I'll see the different profiles, and we'll set up a profile here in just a second. And then in the catalog, I can see, again, here's the full list of catalog or the MCP servers that are containerized. One of the recent additions that we've added is the ability to create a custom catalog. And there's a link in here as well too that I will switch to. Okay, point that tells me how to create a custom catalog. And it is a little bit of a process, so I won't go through all that right now. But the idea of a custom catalog is if your organization or your team has its own MCP servers that you want to share with your team that aren't part of the catalog that we're publishing, well, great. You can create your own catalog. You can publish it, share it with your team. And that catalog can either include your own MCP servers or a subset of the ones that we've published, or others from the MCP community registry. It can come from a lot of different sources. But again, it allows you to create your own catalog. Clients, then I can connect the MCP servers to my, we've got a couple of pre-configured clients that I can just click a connect button here. Or if I've got a client that's not part of that list, here's the commands to run. And then finally, we've got some OAuth support. Right now, we've got GitHub and Atlassian and more are coming to be able to manage OAuth credentials and kind of refresh tokens and everything around that. Okay. All right. So let's pretend here I've got a project. I want to connect my project. I'm going to open up VS Code, and I'm going to use just Copilot in VS Code. And I want to allow Copilot to access my GitHub repo, look up issues, etc., as me. Now, again, of course, I could set up the agent to be able to use the GHCLI directly on my machine, but then again, it's going to need to have access to those different the different tools and the credentials. I have to have the CLI installed, etc. So what I'm going to do is I'm going to create a profile. I'm just going to call this default, and then let's just search for GitHub. Okay, and I'll see that there's GitHub official. I'm going to hit plus here. And then I'm going to select my clients. And since I said I'm going to use VS Code, just move the Zoom window for a second. Okay. I'm going to use VS Code, and I'll hit create. And so at this point, I've got my server configured. I've got a client. And then what I can see is in the tools, I can see here's all the tools that are available. And I can choose whether to, maybe I want to disable certain ones. So maybe I want a read-only profile, and I can go and disable, maybe I don't want to provide the ability to create branches and update files or whatever. So again, I have the choice of what tools do I want to expose through this. I see a question as well too that came up of just the difference between MCP and connectors. And in many ways, they're kind of solving the same problems, more or less. But MCP is I would say more of an industry standard. That what it's allowing me to do is exactly kind of what you're seeing here is I can configure MCP servers and then connect them to a lot of different agents and a lot of different tools where many of the other agents, so for example, Claude has their Claude connectors, but a Claude connector can only be used with Claude. I can't then say, well, hey, how can I use that same config and now use it with Gemini or Codex? Or again, if I want the flexibility to be able to swap between different agents for different workloads, I need a tool that lets me do that. And MCP is a standard that helps support that flexibility here. Okay. All right. So again, I've got a profile that's configured now. And now what I can do is if I jump over to VS Code, I should be able to list the servers, and I see that MCP Docker is configured here because Docker Desktop configured that for me. I just need to start the server. And I'll see some output here. It discovered 48 tools, and I can go to that, and I can say, show the configuration, browse resources, et cetera. So there's some additional details that I can see there. All right. So first off, I'm going to ask it, tell me about my GitHub profile. Who am I? Okay. And what we'll see here then is that Copilot is going to use the MCP server and a tool called Get Me. All right. And I could see the details of that. I can see the output of that particular call. And then I can see some details that the model provides for me. Okay. So for this particular project, I will switch over to my browser. I've got this is just kind of a silly demo app that I use. I've got an issue here that's make updates to the website. So again, as I'm starting to use AI more, I may want to say, can you help me complete the work for issue number 1 on this project? Okay. Now, in order for this to work, it needs to have access to be able to get the issue details. Now, of course, I could just copy and paste it, but if I'm wanting to give more autonomy to the agent, I want to be able to just describe what it is that I want it to do and then let the agent go. Okay. So in this case, it knew that it needed to go read the issue, and it extracted the details out from the just get remote config. And now it's going to go to work, and it's going to figure out the changes that are needed and then apply the updates to this. And I won't sit here and watch it go. I mean, we can see what it's going to do. It's going to read these files. It's going to make changes, et cetera. Okay. But the important thing again is I'm using MCP to connect the agents to external tools and do so in a way that ensures that credentials are safely provided. The tools are running in isolated environments. And it may be hard to see. I'll try to pull it up and see if we get another tool call. Maybe I'll just run the request earlier. Tell me about myself here. We should see a container startup for the, I'm going to tell it, check my profile again, please. And what we should see is another MCP call. It'll spin up a container here. Oh, no, didn't see it. That's okay. It just happened so fast. But again, these Get Me MCP servers are going to launch containers. They're running in isolated environments. I don't have to have anything installed on my machine. And if any of those MCP servers have a compromise in them, I don't have to worry about the impact from that as well. Okay. All right. So to recap what we've talked about so far, because I know we've talked about a lot. Okay. And then also what's next. Again, autonomy brings productivity. We want to be able to allow these agents to be autonomous and to just go at it and be free. But in order to do so, we need to have some guardrails in place in order to be able to do that. And as we've thought about this, again, thinking about agents as these microservice architectures where, okay, the agent harness is going to run, what are the things that it really needs access to, and how do we protect it? How do we give it access to the tools and other things that it needs access to? Through MCP servers. Again, how do we run each of those MCP servers? How do we inject the credentials and the configuration and things that they need to have, but also again, limit the impact if something goes wrong. All right. Where we're going next with this is, for the most part, what I've showed you is things that I can run locally. I can set up network policies, great. But in organizations, especially in enterprise environments, they want to be able to set policies that span across the entire organization. And they need a little bit more insight and control into what's going on. Okay, so how do we turn experimentation and the things that we're doing into production-ready AI? So again, providing audit trails for every action that's being performed. Sorry, mouth is getting a little dry. Policy controls. So an organization can say, here are the tools that we're going to allow and not allow, or maybe these are the agents that we're going to allow in our environment, or the models that are allowed, and the network endpoints that are allowed. Again, allowing an organization to set those kind of controls. If something goes off the rail, well, how can I provide a kill switch to just kill it? Again, if this is running a sandbox, I still have a way to say, hey, kill that micro VM. It can't take control of my whole host, lock me out, etc. Okay, I still have an ability to do that. And then I won't go through all these other ones: PII redaction, credential management, integration into security systems as well too. Again, these are the things that we're looking at. Obviously, this is a little bit more towards the enterprise and larger organizations, but a lot of these capabilities you see manifest even in the free version that we've got now. So to recap here, at Docker, run agents freely, yet make sure that they're running safely. Before signing off or looking at more of the Q&A as well too, since we'll have a couple minutes as well too, I do want to give a shout out. So one of my colleagues, Oleg, is going to be doing a workshop tomorrow from isolation to trust, in which he's going to be getting even deeper and hands-on and guiding you through quite a few different things as well too. And Oleg's been doing some really cool stuff with sandboxes and even using clause. And it's been funny sometimes. He's just like, all right, I needed an agent to go do something. He pulls out his phone and is sending a Telegram message to his claw that's running in a sandbox, and it just goes off and does some work. So some pretty cool stuff there. A couple QR codes here. We've got links to docs, as well as there's a quick start that another colleague of mine, Mike Coleman, put together that goes through kind of a scenario of, here's a project and let's use some prompts and have it make some changes, and it's using sandboxes along the way as well too. So again, quite a few different things here. Off to the right here, there's a QR code. We've been starting to build out some more labs. And the AI labs, we don't have sandbox labs quite yet. We're still working on some of those. But if you want to learn more about Docker and containers and even some of the AI fundamentals or MCP gateway, et cetera, we've got quite a few different labs that you can experiment with and play with there. And then finally, down in the bottom right corner is just a QR code to my LinkedIn as well too. Feel free to connect with me and send me messages or questions, that kind of stuff. I'll try to do my best to keep up with everything. But yeah, that's it. So thank you. Hopefully you learned something new and are excited for sandboxes. And with that, I think we've got a couple minutes for questions, and we'll go from there.
I can help you run through some questions that we got through. Let me just bring it up. Sorry.
Yeah, I'm scanning through it as well too. I like how many folks are using the Q&A to say awesome and thank you, and I say thank you right back to you. So thank you for doing that.
There's one question that might be interesting. Can we set up MCP registry which shall only allow teams to use approved MPC server lists to restrict the occurrence of a threat?
Yeah, great question. And so that's exactly where the custom catalog feature is going. It's not quite there yet to say, hey, within my organization, you can only use the MCP servers in this custom catalog, but that's the next step basically. So an organization can set that policy and say, these are the trusted and approved MCP servers for the organization. So not quite yet, but it's coming soon.
All right, let's look through.
All right. I see one question. How do we ensure that the MCP servers are running in isolated environments? So anytime that you're using the Docker MCP toolkit or even our open source MCP gateway, those MCP servers are always running in isolated environments. They're going to be running in containerized environments. And so you can, again, rest assured that that's the only way that they will run, are in those isolated environments.
So which which LLM will be using? So we have a question, since it launches the MPC server into a container, which is cool. Which LLM will be using it? Do we need to create one, or?
Yeah, good question. So just a quick time check. All right, I'll explain just a little bit. So the way that MCP works is actually there's no LLM at that part of the process. And in fact, maybe it'll be a little bit easier. Let me find another diagram. So when MCP is being used, the way that it works is okay. I'll pull over this slide. Hurrah. Okay, so when an application, so for example, Claude, let me make this full screen. Okay. When it's going to send information to the model, the LLM, it sends, here's my request, here's the prompt, et cetera, here's the conversation history, but it also sends a bunch of details of here are available tools for you to be able to run. And so what then the model does is says, hey, based on this conversation, do I need one of those tools to execute? So for example, when I asked earlier, hey, tell me about my GitHub profile, okay? The model got that prompt, tell me about my GitHub profile, but then also saw that there was a tool description that says, hey, here's a tool that can look up a user profile. So then the model responded back to, in this case, it was Copilot, and said, hey, can you go run that tool? And then Copilot then delegated the work off to the MCP server to say, hey, go execute that tool and then give me the results. So then the MCP gateway spun up that MCP server running in a container. The GitHub server fired off the request, got my profile, brought it back to the application, and then basically sent it back to the model and said, hey, you requested this tool execution. Here's the data from that tool execution. Now, can you continue the conversation? So with that flow, MCP doesn't need a model. Now, of course, there are some MCP servers that can certainly use models. If there's an MCP server that says, hey, for this tool, let's summarize some content or whatever. But in most use cases that I've seen, an MCP server itself doesn't use a model directly. It's being executed because a model has indicated, hey, I need data that an MCP server can provide. So hopefully that helps make sense a little bit there. And feel free to actually, we've got a lab here that's, switch over to the browser here. This AI fundamentals for developers lab actually will go through that of, okay, what's the model interaction look like? How's tool call working? How's tool call work? How do MCP servers work, et cetera? So to kind of dive in deeper into that flow, check out this lab.
Yeah, no, thank you so much for this walkthrough today, Michael.
Absolutely.
It was clear and I was able to follow along, and it's great to learn how to set up a kind of, connect to things safely, but also set up that kind of safe, isolated environment. And we will take a 7-minute break until our next session. So
absolutely,
go grab a coffee or whatever, or water or whatever you need. And we'll be back in 7 minutes and we'll start the next session. Thanks so much, Michael.
Fantastic. And thank you, Rebecca. And thanks everybody for joining in, and hope you enjoy the rest of the conference. Thanks all.
Yeah, thanks for all the questions and engagement. Take care. All right, welcome back, everybody. So our next item for today is we're looking at AI agent on AMD GPUs. So this tutorial basically teaches you how to create, a personal AI agent from scratch, without the need for those sort of third-party dependencies, or those sort of like ongoing API fees. So you'll learn how to put together a tool using agent that is private, it's adaptable, designed for actual workflows, using open weight models hosted on AMD GPUs and agentic frameworks like OpenClaw. So hopefully this can help you save API costs for one, keep complete control of your stack, and host and run open weight LLMs on AMD GPUs. And you also create, a tool using AI agent that is, actually prepared for production workflows, utilizing modern agentic frameworks. So Ida Shah and Maddie Gotzi will lead this tutorial, and I'll hand it over to them to start the tutorial.
Hello, everybody. My name is Maddie. I'm an AI solution architect at AMD. I'm with Ida here. Ida, you want to introduce yourself?
We'll just share a microphone.
All right. So what we have for you guys today is a quick presentation on kind of a background of what is an AI agent. We still, I feel there's, a bit of a gap on understanding the difference between LLM to an AI agent. And that's kind of evident when we have candidates for jobs and I interview them. And one of the questions I ask is, can you distinguish between the two? And for that reason, I think it's good to give it a background. We'll walk through, how it kind of started and how it's evolved. And then we're going to end the session with Ida going through a tutorial that we have prepared for you guys. So you can actually, in this session, we're going to actually introduce you guys to AMD Developer Program, where you can actually get free AMD GPU credits. So you'll be able to actually run this tutorial later on your own with those GPU credits. So we'll get to that. Watch out for the QR codes that we're going to show for how to sign up. But for now, we're just going to get to the presentation. We also have the QR codes for LinkedIn for me and Ida. Feel free to connect. And if you have any questions, you can message us. But without any more delays, let's get to the presentation. So in terms of the foundations, the first question would be, what is an LLM? And I'm not going to bore you guys with going too much in detail, so make it quick. So basically, LLM is a large language model, and as its core, it's a text prediction engine. So you give it a prompt, and it predicts what the next most likely tokens are. That's the whole mechanism. It's trained on massive amount of text, so it's incredibly good at this. But the thing is, to understand why this is different than AI agent, you need to kind of think of it like this is the smart book. It's a very smart book that you can ask questions, and it'll know the answer. But that is kind of to the extent that it goes. So if you look at the right column here, what it cannot do, it can't act or on external system. It can't maintain memory for conversations. It can't run a multi-step process on its own, and it can't check whether its own output is correct. So this gap between what an LLM can do and what we actually want is exactly what this whole workshop is about. Everything we covered today, it's essentially about closing that gap. So let's look at how we close the gap between going from LLM to an AI agent. The first step is going from LLM to a chatbot. It's actually pretty, natural how that happens. So we first started LLM, you can prompt it, you get some response. But then we had the need for actually having some sort of memory to remember what we asked it before. So that's when the chatbots were evolved, and then they got better and better. We even had systems like RAG, where you can actually give it documents and it will refer to that and respond to you. Now, from chatbot to agents, that's where things get a bit interesting. You're adding three things here. Not only are you adding memory, you're adding planning and the ability to take real actions in the world. The agent can run code, call APIs, read and write files, and it can message, based on the needs you have. It critically runs in a loop until the task is done. And we're going to get to the loop in the next slide, and that's one of the most important concepts of AI agents. Okay, so the loop that we were just talking about is known as a React loop. How does an agent actually think and act? The dominant pattern is called React, which is short for reasoning and acting, and it observes whether the job is done or not. It came out of a paper about 2022, and it essentially became the standard approach. The loop has 3 steps. First, the model reasons about what to do next, what's the current situation, and what's the goal, and what should I do now? Then it acts, picking a tool to call, maybe it runs some code or make an API request. Then it observes, it reads the results of what action it did, and then observes to make sure that's done. To make this concrete, you say you ask the agent to fix a failing test. It reads the test output, sees the error message, reasons about what's wrong, edits the file, runs the test again, sees they pass, and stops. That's 3 full loops of thought, action, observation, with no human involved at any point. So why the loop changes everything here is a good question to ask. And I think this is one of the core concepts that we need to grasp really deeply to have a great agent. And I think working with different agenting frameworks that I've done in the past couple of years and agent products, one of the reasons I believe some products like Claude Code is very strong is they have a really good loop design that it actually figures out how to solve a problem that you throw at it. So without a loop, you're basically asking the model to solve a problem in one shot and just hoping to get it right. You have no idea if the fix actually works or it's complete. So with a loop, the model can run the code, check the output, and verify its own work. That verification is the part that it decides whether it needs to stop or go back to the beginning of the loop. So when people obsess over which model is the best, sometimes the smaller model actually do a good job in this loop compared to bigger model at one shot. So having a great agent loop is very important in your whole agenting structure. So this is a part that I kind of made this in my own language of what are the recipes of actually making an AI agent? What are the main core components you need? And I kind of like this slide because I've myself experimented with this to see if you can actually build a self-expanding or self-learning agent with the minimal code and kind of let it evolve as you need. And this is totally possible. And that's one of the things that OpenClaw did really great. And that's one of the reasons that it's very popular is like they made a really good software that can act as your agent for general purposes. So the 3 components that you need to be able to build an AI agent are the model, the runtime software, and the tools. The model is a reasoning engine. It decides what to do. The runtime is the plumbing that keeps everything running. It manages the loop, handles context, execute tool calls, and deals with failures. And the tools are basically the hands of the agent to be able to interact with the environment. So cases like reading files, accessing API, code execution, sending messages, or whatever you give it. So this like 3-part mental model is going to come up again and again through this workshop. And by the end, you'll be able to look at any agent system and immediately map it that, okay, it actually literally is built out of these 3 components. So the model, that's the first component you need. And intentionally, I'm just pointing out the open source models because this whole workshop is not about sign up as APIs that are super expensive, or some of them are currently banned for some of the agent software. So OpenClaw, for example, you can't use it for certain subscriptions. So let's see how we can leverage open source models. And the ones that I've picked here are more of the recent or, my personal favorites right now in terms of the open source models that you can use for any sort of agenting framework. Gemma from Google, Qwen3 from Alibaba, Kimi from Moonshot, Minimax from Minimax, and then GPT-OSS from OpenAI are some to highlight here. Each of them have a their own strength. But one common thing about all of them are they're capable of tool calling, which was a trend that happened about a couple years ago. The models started to be really good at calling tools, which allows us to have agentic applications. And these are the models that I want to highlight in terms of the most recent and capable open source models that you can run locally as long as you have the compatible hardware. So the next one is the agent runtime. And that is the piece that most people underestimate. It's honestly the most important one to get right. The model gets all the attention, but runtime is doing a ton of work every single turn. It assembles the prompt in the right order. It catches the model's tool calls. It executes them safely. It handles failures, and it feeds the results back for the next iteration. Look at the concrete jobs listed here: prompt assembly, tool execution, guardrails and recovery, integration. That recovery piece is really important. It retries, times out, approves flows, fallbacks. And that's what separates an agent that works most of the time from one that actually you can rely on protection. The runtime is also where context management lives. Conversations get long, and at some point you're going to hit the model's context limit. So what the runtime does at that moment, whether it just dies or gracefully compacts and continues, it all depends on what sort of runtime software you have. And the last piece of the recipe that we need to talk about is the tools. I saw the previous session right before here, we talked about MCPs, and MCPs been a standard for agents to be able to access a set of tools, but there's more ways you could do that. So we have custom tools that we put on the left side. What it means is you can basically have any sort of functionality you need, write a custom function and pass that to your model in a very structured way. And the model should be able to understand the tools that are available and run it when it's needed. It could be a Python function, a REST endpoint, or any sort of way that you can package that software with the structure that the model needs. And on the right side, there is the typical ways that are right now out popular. Like CLI is very popular right now. MCPs we talked about. It could be the APIs. So all of these are the ways that you can actually pass that context to the model during runtime and say, hey, you have access to these tools. And each model has its own chat templates, which understands these tools are available and will be able to call them when it's needed. So all of this work kind of came to this whole idea of, okay, now we get a lot of open source models coming. There's a lot of APIs for the models to use. So it kind of led to this whole explosion of what I call the framework explosion. In the last couple of years, I've been watching and playing with a lot of these frameworks, and you can see that you probably noticed that there was a kind of explosion that way. I feel like every week you'll see a new project coming out. But here's a useful frame for all. Like all of these frameworks, every single one of them, are solving the same sort of problems: loop orchestration, context management, error recovery, and observability. The abstractions look different on the surface, but underneath, they're basically trying to solve the same problem: how to build an AI agent with different methods. To kind of highlight some of the most popular ones, I made a list of them. And these are some popular frameworks based on the stars I saw on GitHub. And if you can look, each of them have some sort of capability in a way that could be more attractive to one developer compared to another, or based on your project, maybe you prefer one over another one. LangChain was very good in terms of having a complex pipelines that you can use a graph to build a nice agentic pipeline. Crew AI is great for multi-agent coordination. Then we have Llama Index, which was used a lot for making RAG application, and small agents by Hugging Face was great at doing a code-first approach to get the agent to write code when it's needed instead of just using tools all the time. So all of these are valid. And if you're starting a new project and you want to move fast, you can pick any of these and it'll work. It'll do a great job. I've personally done a lot of work with different of these frameworks that I listed here, and they do the job really well. And I used to do that a lot. up to, I guess, like, December or around that time, where I realized, there's a lot of our needs can be actually done without you writing all these custom code and importing these libraries. And that's kind of the angle we want to take this talk at, that, for, I'd say, depending on what you want to do exactly, but there's many things that we do here that we used to write our own custom software. But now leveraging some of these mature agent products, such as OpenClaw or Claude Code, you can actually get away without writing much code. Just allow the agent to access the tools you have, and it'll have a really great loop and capability to expand its capabilities to get the task done. So this is where we get to the OpenClaw approach. So what is cool about OpenClaw, and it's, you've probably seen that all over your social media or online, that everybody's talking about OpenClaw. The fundamental difference is one of them is a framework. All the ones that we talk frameworks are libraries, which you import them in your code, you write the loop, and you run a script. And when the script finishes, everything stops. On the other hand, OpenClaw is not a framework. It's a persistent process. It's an agent that you can change based on your needs. It's always running on your machine. And that distinction, always on versus run on demand, changes what's possible. So you can think about cron jobs, or if you want to have an agent produce something on scheduled time. It just fits naturally into this sort of mindset of you want to have an always on agent that you can modify for your need and have it doing the tasks that you need. There's a lot of little details in OpenClaw that we can kind of get a little bit deeper into in the next few slides, and then Ida is going to actually show a live demo of how you can actually get an AMD GPU to set up your OpenClaw for free. And you'll get more familiar with the concepts. So I'm kind of going to give you a little bit of a very high level abstract overview, but you'll have the opportunity to play with it and see it, yourself, how it actually works and how you can get your tasks done with an agent product or a runtime, such as OpenClaw. Kind of like give you, again, like a top level what happens when you send a message. Let me walk you through exactly what happens when a message comes in step by step. A message arrives, could be from Slack, Discord, Telegram, or some sort of messaging app that you set through the channels plugin of OpenClaw. It goes into a session lane. Every conversation has its own serialized queue, one turn at a time. That means, a long running task in one conversation never blocks someone else asking a quick question. So it's concurrently can be prompted with multiple, but they're all having their own unique QID. The prompt gets assembled. That's the bootstraps all the files, tools, schemas, and conversation history are all put together in a deterministic byte order by byte, and it's passed to the model. So the model gets all of that, and it decides what to do based on the model you use. And, if it needs a tool call or just respond, it generates everything together, and at runtime executes it and appends all the results and pass it to the loop. And the loop determines, how far it should run, and when it's ready, it will respond back to you. And again, all of this is running on your whole machine, depending if you want to use the model in the cloud or the model on your own device. The agentic part is all running on your machine, so it has full access to your personal environment. Most AI tools are reactive, so when you send a message, they respond and they stop when they're done. On the other hand, OpenClaw, since it lives all the time, it treats time and events as a first-class inputs. So a cron job that fires at 8 a.m. is just another message to it. A webhook from GitHub is just another message. Heartbeat timer is, again, something that invokes the agent. The heartbeat example is really simple, but I think it's powerful. Imagine you're monitoring a service. You set a timer to fire every hour. The agent checks the status, decides if there's an issue and that needs addressing, and either acts or stays quiet. So that's the difference between a tool and assistant. A tool waits for you to use it, and assistant is always there for you to help. How the agent, wakes up is another topic that we want to quickly go over. This is something most people never think about, but I find really fascinating, and especially the first time you interact with OpenClaw, something special about it. You feel a little bit more personal. So to kind of like go over what happens underneath, the agent just doesn't start. It wakes up already knowing a ton about its environment because every session begins by assembling a rich structured system prop at runtime. So on the left side, you can see what goes into it first. First, the full tool list. Every tool available in the session with a schema, so the model knows exactly what it can call. Then the skills catalog, but just the names and descriptions. And the actual content is loaded on demand when the agent decides a skill is relevant. And then the bootstrap files, which are just the markdown files that, sitting in your workspace that get injected during the runtime. These bootstrap files, MD files that we're talking about, such as agents.md, is where you put a lot of instructions for the agent. So each of them has its own role. And this is another beauty of, very clever design of your runtime agent. So agent.md is where you put your rules and instructions for this workspace. This is one of the most important files you have there, along with solo and MD. And that's where the model plays a big role. If you use a very powerful model and you have a longer context, maybe it will do a better job at remembering all of that. But as you get to smaller models and maybe a little bit less powerful, that's where you should be able to know that possibly you need to go modify these files like the soul.md or agents.md because you could start to see the pattern of maybe the agent forgets the stuff you want to say. Maybe it doesn't do exactly what your agents.md describes. And that may be because you're giving too much context or you maybe not accurately describing everything. And as the models get smarter, they can maybe handle all of those. But since we're talking about using open source models, you need to be careful about setting these correctly. Tools.md is another one where you actually have documents on your local environment, host names, scripts, or camera names, or whatever you have. And then there's memory.md, which is automatically taking notes as you ask it. So if you say, hey, remember to do this next time, it should take a note and put that in a specific file, and that is your memory.md. On the right side, the runtime section is injected last. That's the current date and time, the host OS, the active model, the thinking level, the session ID, what model to use, all of those will be also injected in there. So if you want to change how the agent behaves, you just need to, change these MD files that we talked about. In the next session, it actually wakes up and it knows that, those changes are applied and it will do it. And you get a bit of that in the workshop that Ida is going to go through and, get a hands-on experience with that. The next slide is something I kind of covered, but it's also another cool part about OpenClaw where the concurrency is one of the things that, it's a native approach. Everything else is on its own thread. So you basically have one thread per session. You have the session ID, so it kind of reduces the possibility of having some race condition and having conflict and messages going into the model. So OpenCloud's done a great job of making this. This also brings the question of so how about the multi-agent system? Does it allow the communication between agents? And that is something I didn't put in the slides, but to just briefly answer that, because that comes naturally, is yes, you can actually have multiple agents talking to each other. That happens in a few different ways. You can actually have one agent invoke another agent. You can have an orchestrator, start a couple agents. You can have shared spaces with your agents. So you have a lot of flexibility on having multiple agents communicating with each other. In terms of tools, this is again something that I think there's some sort of misunderstanding about OpenClaw and maybe MCP or how it does. It's very flexible. You can connect your MCPs to it. You can connect your CLI tools to it. There's many different ways you can actually have your agent expand itself and its capabilities by allowing it to connect to different set of tools. There are already MCP servers such as GitHub, Postgres, or Slack, Stripe, and there's a lot that you can use, and you just point your OpenClaw, and it will create a session, and at the end of the session, it closes that MCP connection. The plugin system is the other half of the extensibility of OpenClaw. Plugins are how you set your model providers, your messaging channels. So that's one of the very cool things about OpenClaw was they wanted to bring it to you with your existing messaging apps, and that's through channels. You can have your Telegram or your iMessage, whatever you prefer, all connected to it through the channels. You can expand the tools. You can create custom skills. You get a little bit of that through the workshop that Ida is going to show you. And each of these plugin declares what it does in a manifest file, and Core discovers everything it needs from that manifest without loading the plugin's code. So plugins can fail without crashing the gateway, and they're only loaded when they're needed. So there's a provider plugin part that we're going to take advantage of in this session as well. So really nice thing that happened with OpenClaw was after it was created, at first it was basically all paid APIs, but slowly you could see immediately there was different projects being added, such as Olama, VLLM, SGLang, which all allow you guys to run your own model and be able to connect it seamlessly. And you get a little taste of that today as well on the Ida's part. And last thing to mention, a lot of these plugins install via npm, so you can actually have a service added to your OpenClaw and be able to use it on the fly. Another fascinating thing about OpenClaw was that I loved about actually the first few times I used it. It's very self-aware. So it actually knows exactly about its own source code and how to fix a problem. So most of the time when you actually have a problem, you want to add a model, you can actually prompt it. You say, hey, I have a second model I want to add. I'm running this local model, but you're not understanding when I try to manually configure it. You'll give it the information it needs. It can actually get those information, apply the changes, restart its own gateway, and get that running for you. The first boot.md to get drop. It's a markdown file in your workspace. When the agent starts up, it reads the file and acts on it. So you can say something like, check if the camera feed is reachable, then ping me, and no code is required. So these kind of flexibilities that were added in OpenClaw, I found it really fascinating. And again, you gotta get to see it yourself when you start playing with it. But just wanted to touch on this whole idea of the agent is self-aware, and that's another cool thing about OpenClaw that I wanted to cover. Also touched on this very briefly. The agent can restart its own gateway. This is very powerful because a lot of times you need to basically modify, say, for example, I'll give you one example that you can try again on your own. If you add a model and you don't set vision for that model, so for your agent, sorry. So if your agent has connected to a model, and that model is actually a multi-model, such as Qwen 3.5 that you're going to use, and you send it a picture, it won't be able to understand the picture because you haven't set its vision part. But you don't need to go figure out where the config files or how to do it. You can just literally prompt the agent and say, hey, like go fix this because the model is Qwen 3.5 and it's multi-model. It'll be able to go find the config file, fix it, and then restart itself. And then it'll respond to you, okay, I fixed myself. So this is a fascinating thing that happens. I kind of like structured it in this slide, but just wanted to quickly touch on it. So this is all about OpenClaw and how it evolved from learning from all of the stuff that people have done with agentic frameworks, and I think it's a very interesting time to have a project like OpenClaw coming to you guys for free, open source, and kudos to the maintainers and the people who created it. But let's put that in practice. How do you guys can get that running for free, especially if you were recently banned from your API, by certain providers? You don't have to rely on providers, you can actually get a lot done. Maybe it's nice to have a secondary provider that, you know, you want to have the latest, greatest closed source model. But today we're just going to focus on open source. We're going to cover Qwen 3.5. This is a family of the models were dropped not even a month ago, I think. They're very recent and very powerful. So I've been using this model since it was released, and it's been doing wonders for me. So hopefully you can also get it running and do what you need to. But in today's session, Ida is going to use an AMD MI300 X GPU. So that is AMD's, you know, I think about 2 or 3 years old now, but it's still one of the best GPUs you can get as a developer at a very low cost. We actually give you $100 free credit today. And the next slide, you should be able to scan that and request for your credits. But that gives you 192 gigabyte of memory. So what that means for you is when you look at Hugging Face model cards, when you come across something like Qwen 3.5, 12020B at FP8, that means each parameter of the model weight is 1 byte. So you should be able to, you know, run the model comfortably on a GPU that's 192 gigabyte, assuming that's, you know, enough KB cache to cover your context length, then it's perfect for you know, a GPU such as MI300. On AMD's side, we've done a lot of work to make sure that we have day zero support model. So models like Gemini 4 that was released last week had day zero support, and it's continually doing the same thing for most, or I would say almost all the models that you hear about open source. They all have day zero support. And a lot of that is supported by working with community. So this is a slide that kind of like wanted you guys to maybe take your phones out and scan. So that QR code should allow you to get into the AMD developer program, which you have $100 free credits. You get a month of deep learning AI subscription, and a bunch of other benefits that are listed there, and they keep continuing to be added. So we have a lot of partners at AMD, and you know, you will be the first one to get that benefit as an AMD developer. So I'm going to leave that for a few more seconds for you guys to get a chance to scan and take advantage of AMD free credits through AMD developer program.
Which is also free.
It's free. Everything is free. AMD does not charge developers for any sort of these subscriptions. So free for you guys. Okay. There's also events coming up. If you haven't heard, if you're in San Francisco or Shanghai, China, there's 2 AMD developer events coming up. So please check out once you create your account, and you'll be able to access those events. I was just going over how this is possible, and I'm quickly going to pass it to Ida to basically share her screen and show you guys a quick lab we created for you guys. If you haven't heard of VLM or SGLang, they're probably the 2 most popular way that you can run models on data center GPUs. So they're both open source, and they allow you to run models in a very efficient and fast way on different GPUs, including AMD. So we're proud to have you know, very tight relationship and integration with those 2. So you'll be able to use either of them to run, you know, Qwen 3.5 or models like that. And you're gonna get a taste of that again in a few seconds. The model is Qwen 3.5 I talked about in the lab. You're going to see you can run that on different AMD GPUs. You know, MI300 is one of the ones. We have MI325, 355, and 400 series coming. They just get bigger and better in terms of the memory and throughput. This is just about the model, how it's, you know, can be a hybrid attention. You can do linear attention or full attention with this model, and it's really powerful. And it's free for you guys to use. For the rest of it, I kind of want to pivot now and pass to Ida. So she'll do a, you know, a live demo that you guys should be able to access later when you sign up for AMD Developer Program. You can also reach us again on LinkedIn if you have any questions. But at this point, I'm going to finish this part of the presentation and pass it to Ida to go over the lab.
Awesome. Thank you, Madi. Let me just share my screen real quick. Okay, awesome. So like Madi had said, for the AMD developer program, if you join it here, you will have the access to $100 of free GPU credit. And then with that credit, if you go, the rest of this will show basically on Developer Cloud. And so once you sign up here, you can go to our AMD Developer Cloud to create a droplet. And so here you'll see you have access to the MI300, and this is only about $2 per hour. And so I think some folks were asking, oh, am I going to be on both cameras?
I think they'll see the cameras highlighted, so that's fine.
Oh my gosh. I guess you'll get two angles here. So yes, so you look at the credits for the MI300, it's only about $2 an hour. So with the $100, you'll get around 50 hours. And some folks were asking, this is a way to get around those really high API costs you might have. So if you're using OpenClaw with like some API endpoint that's charging you per tokens, hosting it yourself locally will save a lot on those costs because there's no rate limits there, no cost like per token. All right, so once you get started here, we're gonna just show you basically the example using VLLM, but like Madi said, you can also do it using SGLang. So you would choose the VLLM image here and then create your droplet. So we already have one running. And then there's already going to be a public IP for you to go to where you can see the Jupyter notebook. So let me do this one. So once you have it started, this will just take a few minutes for the GPU to provision and to set itself up. You can upload the workshop. So Madi is we can share the link to this repo. This is also where we'll upload the PowerPoint afterwards. So we'll share this out. It's a public repo. It has the workshop in it. It has a few other great workshops that Madi has put together as well. But we'll go through the OpenClaw one here. So you can upload this directly into the Jupyter server by clicking the upload button, and then wherever you downloaded your workshop, you can just upload it here. So the workshop really goes through everything you need to start your OpenClaw and host your model locally, set up skills, everything you need to really get started. So the setup here, this is just doing the VLM serve. Again, if you're using SGLang, it'll be a very similar, you'll just serve the model using SGLang. So we already have the model started here. Again, if you go through the notebook step by step, it'll have this all. We just have some of it done ahead of time to save some time here. So since we already have this running, we can check here. Cool. And so the server is already running. And then this is when you start onboarding your agent. And so you'll run OpenClaw onboard, and then it'll ask you a few questions. This is just for configuring it to the model serving. And this is what you will fill out. So we already have that done here. It'll look something like this once it's all configured. And then you'll just need to start your gateway, and then you can start OpenClaw TUI. So this is a terminal UI. Like Madi had said, you can also hook this up to like Telegram, WhatsApp, and then you can just chat with your bot on your phone, which is pretty cool. So here we're just going to run in the terminal. And so when you first start, it's gonna ask you some questions. So it tries to be very personable, and so you can set a lot of information. So it's like, what do you want to call me? Kind of like, what am I? What's my vibe? And then any details. So here we can show you. So by default, it'll be empty. So real quick. Madi mentioned the markdown files that got passed along with the request to OpenClaw. So here you'll see this is still empty. So it's still asking, this is just metadata, still figuring it out. And if we chat with it here, it'll go and update that file. And so it'll persist its identity. So here we can, let's just do an example. Your name is, let's say, Bisque. also sneak peek at potential swag we might have at our future events. So if you like lobsters and or open claw, make sure to come by. So your name is Bisque, and an AI assistant. Let's say, please be casual and chill with me. I am a software. And so it'll be thinking, and again, you can see it's using your local VLLM instance. So this isn't going to have like charges for every like token you send it and stuff, because this is just running locally. So now it's saying perfect. Let me lock it in. And it will be writing basically to that identity file. So here it's just confirming, and it's letting you know it's done, asking what you kind of want to get started with. And if we check here again, you'll be able to see it updated its identity file as well. So it's going to persist this basically throughout your conversations. And it'll know its name is Bisque, it's casual and chill, and information. And so there's a lot of files like these that kind of like tell the bot who it is, how to interact, what tools it has, that kind of information. And so this notebook will also go through all of those details. So this is like the soul file, that basically is probably things you have all seen before around guardrails, like be truthful, be helpful, be nice kind of situation. And yeah, so this is basically how you set it up. And so it's really quick, it's really easy. Again, this is running on an MI300. It's using a pretty large Quen model. And so it's very powerful.
Model ask what model it's running.
Like, yeah, so like a lot of this is all autonomous too, right? So you can be like, what model are you running? And it will let you know. Awesome. So yeah, the Quen 3 model, 122 billion parameters, large context window.
I guess that we can maybe also show that how RockMSMI is also showing GPU utilization and VLM, just so everybody's familiar.
Yeah, so you can use RockMSMI to see the GPU utilization. So you can see here the VRAM is up because the model is loaded into the GPU. And then if you send it a request, so tell me about this one. You can see the request make it to the VLLM endpoint here, and then you should see the GPU utilization go up as well.
Watch.
Yeah, it's better. The keyboard just. So you can see now the GPU is also working to process that request. And then now it's also responding. And the rest of the workshop will also show you, go through basically how to set up the skills, tools. You can set up automation. So one of, like Madi was saying, one of the really powerful things with OpenClaw is it's kind of running as a runtime. So it'll actively like ping you and do things for you. You don't always have to like push it to do stuff. It'll do it autonomously. So you can set up like a morning brief is what the workshop will kind of show you how to do, is you can autonomously set up a brief, which I think a lot of people on our team actually do this already, where it's like, oh, watch these repos for me, let me know when there's like a new PR that's like relevant to what I'm working on.
And maybe I'll also like just kind of like quickly walk through this, so people know, because one of the things that I've seen on I don't know, X or Reddit or those online platforms, a lot of people complain about, maybe open source models are not as powerful, but in this workshop, you actually get to play with this yourself, and you can judge for yourself. So the things we've done here is to kind of show actually the opposite. You can do a lot with open source models, and you can figure out a balance between, when you actually need a non-open source model or something that you want to pay for. It's up to you and the tasks that you have set up. But to give you a brief example here, since we have some more time, is in this workshop, we actually have a project that we just created, OpenType Faster, which is basically it's a typing speed project that you can type and show how fast you are. But there's a bug that we intentionally introduced there, and we're going to ask the agent to first go pull the repo, install it on your environment, tell you how to run it. Once you run it, then we'll ask you if you can figure out what the bug is. As a human, you can look at the bug, maybe figure it out. But the point is, with this OpenClaw, you can actually ask the agent to go figure out the bug and fix it for you and make it ready. So that's, one of the smaller things that we can show you that, you can get a single GPU of AMD MI300 to run this model, and it can do a lot of things for you that open source models are capable, and you get to play with it yourself. So there's the cool aspect of, as we talked about, the agent loop, that since you put that model in a loop, it'll actually try to keep going and keep figuring out what the problem is and fix it through the loop. So yeah, compared to maybe like if you were doing a one shot of this model versus a much bigger model, obviously the bigger models of the current time we're talking about might do better. But in a loop, you can actually get a lot done with the same smaller models, open source models on your local GPU. That will be very helpful for you. So, feel free to go through this workshop yourself. As Ida mentioned, you will be able to access that free credits that we have for MI300. Maybe I'll share that last page again for you guys to have the opportunity to scan it again and join the program. Once you have that, you can download the workshop, upload it with this button, and then you should be able to run this workshop yourself. So maybe I'll just switch to my last slide and then have that QR code ready.
And we can do some live QA as Madi gets that. Let's see. Thank you all for asking questions too. There's so many of them. I've been trying to get to the ones I can. There were some questions about the difference between what like an AI agent versus agentic AI is. I think people usually kind of use those interchangeably. I think when people say AI agent, they might be referring to the specific bot you're like interacting with versus like the entire framework. Otherwise, I think usually they're used pretty interchangeably.
It's one of those terms that I think like you can make sure I'm sharing the right thing. Am I sharing? Is it good?
Yeah.
Okay, great.
Cool.
I think yeah, like a lot of these terms, even AI agent and agentic AI, a lot of them are loosely defined, to be honest with you. There's some Venn diagrams you can look up that I've seen that they try to distinguish between the two. But the point of this tutorial is more on the AI agents to be able to accomplish a task, and I hope you guys had a fruitful session with us so far.
What tools can OpenClaw access out of the box, and how do you add custom ones? So the workshop will show you basically this process. So the agent can add its own like skills and tools as well, which is what makes it really powerful. So you can ask it to do something, and it can make those skills for itself to then go and do it. So it's less, I guess, what about like what tools it has, but like the capability that it can basically create all of them.
And I think in the onboarding session, actually, when you started, there was a part that says configure the tools now. We skip it for this, but there's quite a few tools that you have potential to add during the onboarding. So if you want to spend more time and then configure those, there's a lot of that that come as default. But I want to maybe mention one thing. So if you look at other agentic applications that came out in the past few months, maybe inspired by OpenClaw, most of the tools you need, you can actually get the agent itself to add it if you start with some really basic tools. So like the bash tool, the web tool, and web browsing tool, like the web browsing tool, bash tool, and read and write on your files tool. If as long as you have some sort of setup that you start with these, you can extend that agent a lot by literally just prompting it and getting it to do that for you. So a good project you can take a look at is the mini, which will use literally the tools I told you to do a lot for you. So that's one thing to keep in mind.
Rails does OpenClaw provide for retries, timeouts, and approvals?
Production guardrails. Uh, it's a good question. The one thing to keep in mind, this was a hobby project, right? Like the guy, Peter, who made it, wasn't necessarily trying to make this a production. And the first thing you actually press is, do you understand the risks of running this? That is the first question to ask you during onboarding. Because the reason I'm asking it this way is because there is some guardrails. For example, you can read through the MB files that it has, but depending on where you use the agent from, so if you're in a group Telegram chat, it'll deny access to your exec files for SSH or sorry, for bash files on your terminal. But that being said, there is some guardrails there that you can read about. There is also a lot of forks of this project that are basically advertised as enterprise. However, my first to-go file would be if you look at the security files that under OpenClaw, I think .ai docs, there is a whole section that they're dedicated him and a bunch of other security experts in terms of how to make it secure and add some guardrails in terms of whether the guardrails are for privacy, security, or different reasons. You can read that as a reference.
Awesome. I'm trying to see if there's any that were repeated so we can cover more. Madi and I will also just stay in the chat after our session to just finish responding to anyone who hasn't gotten a response yet.
Yeah, no, thank you so much for responding to the questions. And I just thought I'd flag too, whenever you get the time, but it's somebody was having trouble accessing the credits. So they clicked on access now, they created their account, they just don't visibly see the credits anywhere. Maybe we could just help them locate those credits. And then, which is really cool that we have $100 of credits to use. And then I think someone was trying to connect OpenClaw to Quen and maybe just needed a quick overview of how to do that. Yeah.
Sure. How about I stop my screen and I'll Edith, maybe share your screen to show the part that you connected Quen to OpenClaw. As long as you have BLM or CLang, it's super simple because that's already integrated.
Mhm.
I will drop a couple of blog posts that I've written on AMD website that you can refer to in terms of how to get your credit claims. Keep in mind right now, there's a lot of demand on this, so we're making some changes by end of this week to make that a bit smoother. So I think right now you need to request that by sending an email once you get to the platform. So I post a blog post, and a blog post you'll see a section that says claim or credit. It might change right now to say send us an email, and once you send the email, we will review it. And I said we're just making sure that the real developers come in, not somebody's bots or scripts are trying to claim those credits that we have. So make sure you send an email, you'll get your credit. So I'll just post those blog posts. Anita, please show the way that you connected.
Yes. Yeah, so like Madi said, once you log in here, you should be able to see a link to claim the credits. This is changing every so often, so you should double check if you haven't claimed it yet. Okay, so to connect the Quen model to your OpenClaw, sorry, so many tabs, you want to serve the model, and so this is just the VLLM serve command. This is inside of the notebook as well. So this you want to run in a separate terminal, so either VLLM serve, sglang, to start the model. And then to connect it, again, this is in the workshop at the top section here that will go through the onboarding. is what you'll want to run. So I think I can actually kill this now to show you open call. Oh, this is like a different one. So let me grab this one, open call onboard. And then this will basically prompt you for all the information it needs to basically hook up to that running. So again, like kind of Madi was saying too, this is a personal pet project that someone put together. So like you said, your own risk. And then you can do quick start and then set everything. So the model, again, this one example, we're using VLLM. And then you'll fill in the URL that you started the serve command with, as well as the access token. And then it'll OpenClaw will be able to see it.
No, thank you so much, guys, for taking us through all this, and it was super engaging, and it seems really useful. So yeah, awesome work. It was really really engaging. I think we should just take a 5-minute break until our next session. But thank you so much to our speakers, and thank you so much to our participants, our audience, for really digging in and asking a lot of great questions. And yeah, we'll be back in 4 minutes actually until our next session.
Awesome. Thank you so much.
Thank you.
Bye-bye.
Right, welcome back. So our next session is basically, solving agentic AI's infrastructure crisis, powering agentic inference with Samba Nova. So this tutorial demonstrates sort of going from single agent configurations to more fully distributed systems. So going to be using, Google ADK, the A2A protocol, and Cloud Run. And you'll create and implement a kind of scalable multi-agent architecture that kind of, mimics actual production processes. So we're going to create and coordinate specialized agents with the Google ADK and the A2A protocol. And then you're going to install a sort of production-ready, scalable sort of multi-agent system on Cloud Run. So Kwasi Ankama will lead this tutorial, and I'll hand it over to Kwasi to start the tutorial.
Hey, Rebecca. So I've been just to set the scene. So there might have been a slight discrepancy with abstract because I don't think we'll be using Google ADK. I'll just be talking through the infrastructure crisis and taking through Samba Nova and basically talking about some of the apps that we've built, and we can share some of the repos, but we won't be going into Google ADK in this one. So
Okay.
that's just to manage people's expectations there. All
Yep,
good,
sure.
all good, all good. So let me just share my screen. Okay. Perfect. Can everyone see that? Go with yes. Okay, so hi everyone. So my name is Kwasi Ankoma. I am a director of AI solutions engineering here at Samba Nova. And Samba Nova is kind of a full stack AI inference company. We try to solve the agentic compute problem by serving agents that are kind of scalable and compute that is kind of efficient and super fast as compared to other chip providers. So what I'm going to be talking about today is solving the infrastructure crisis for agents as we scale. I think we've heard from everyone that agents kind of run continuously now, which means that they consume much more tokens, and which means that they consume much more compute. And therefore, you kind of need to scale that compute in an efficient way if you really want to scale agents versus kind of adding lots of infrastructure as you scale up as well, which is not always possible. So a little bit of background as to who we are. So basically, we was founded in 2017 out of Stanford. So our co-founders are all kind of professors at Stanford. We have Kunle Olukoton, Christopher Ray, and Rodrigo Lang as our CEO, and we have Lupu Tan as our chairman as well. And we've raised well over $1 billion, and we have around 400 employees, and we're based in Palo Alto, London, and a few other places as well, with offices in Tokyo and Australia as well. So who we are and what we do, and why this is important for, I guess, what we're gonna talk about. So we're a kind of full stack inference AI platform, which means that we have our own custom chip. We have our own integrated rack level system. We have a runtime that allows us to bundle open source models. And then we expose this in 3 products. One of them is our cloud, which I'll show you. One of them is something called Samba Stack, and the other is called Samba Managed. So what I will kind of go through here is some of the key bits around why we think we're good at serving agents at scale. We tend to work at a lower power consumption, which allows you to scale quite well in terms of how much you can put inside a data center. We also have very fast compute in terms of we can run kind of the larger models, the DeepSeeks, and other kind of 500 billion plus parameter models at a very fast speed and on kind of one rack or one node, as we call it. And we also basically support kind of custom checkpoints via kind of a concept called BYOC for architectures that we already support. So if you fine-tuned your model elsewhere for agentic workflows, you can kind of bring them onto our system as well. So before I move on, I'll kind of, talk to a few things that have kind of happened recently. So, we've had this huge rise in usage in OpenClaw. And I think everyone would have seen the announcement from Anthropic, that they're changing their pricing model. And, someone made a really interesting point that the old pricing model was based off the fact that a user interacting with a web portal. So, maybe you have 2 hours of heavy usage, but then the other 22 hours of the day, the user isn't actually generating tokens or using your compute. But obviously with things like OpenClaw and, always on agents, so to speak, you now have agents that are consuming tokens 24/7. And that requires a different sort of thinking, especially if you want to serve a lot of users at a particular throughput and token speed for those users, which agents we know, of course, need as they run kind of a lot of them latency sensitive information. And you're also seeing from the market that there is a signal that people are willing to pay for faster compute. I think you've seen it with NVIDIA with the purchase of Grok and the fact that they announced at GTC this kind of system that's going to try and do prefill and decode on different nodes, on different architectures, one being GPU and the other being custom silicon. And we've also seen it in the signal of the cost increase, right? So Anthropic now charge you kind of 6x to use fast mode, and that's kind of sending a signal that fast compute is kind of here to stay and that people are kind of willing to pay for it as well. So what I'm going to look at now, if you give me a second, is go and kind of show you what that looks like. So before I go into this, I'm just going to very quickly go into the dashboard. So if you want to kind of go to cloud.sambanova.ai, you can kind of follow along. We've got a few just to kind of give you some material here. We've got these kind of AI starter kits where we've actually got live code where we've built applications using Sambanova. So you can feel free to go and use and kind of run these things yourself that I'm going to show you, these applications. And also we have all of our code, we have our Helm chart, so you can kind of go and deploy all of this in your Kubernetes. And we also have an integrations page, so I'm kind of going to show you the documentation here. So we have kind of all of our integrations, and within our integrations we also have a GitHub repo that allows you, we have lots of example code that allows you to kind of go through and build with all these integrations on Sambanova as well. So feel free to go and use that. As I said, I'll be talking a little bit more about the chip, and then I'll kind of go into some of the use cases and applications that we're seeing to kind of show you what that looks like in real life. So if we kind of go to back to this screen, I think what the key thing that I kind of want to get across is the speed of the inference. So if you go here to our playground, and you can again sign up, we give, I think, $5 free credit. If we take a model and we say kind of, write a binary search tree. Now, if you kind of go here, the key thing I'm trying to get here is that we're running kind of 8B at around 1,100 tokens per second. So it's a huge speed increase over kind of GPU. And obviously you can do this for other models like GPT-OSS, and we run this kind of a lot quicker than a lot of the GPUs in the market as well. So one of the key things that we're trying to do at the moment is, you can see here, we've kind of got to do 769 tokens per second. And so again, super fast inference on some of the larger models, which makes a big difference when it comes to agentic workflows. So I kind of wanted to show you, you can kind of go and play with that at your leisure, and it's all OpenAI compatible. So it will integrate into any application that you've got at the moment. And again, if you have any questions while I'm going through this, please shout, and I'll try to answer them as well. So I'm going to talk a little bit about what matters to agents in terms of metrics and how workloads are served. So if you think about what's happening under the hood, you've kind of got two key things. You've got the client and the server. So there's three key metrics here that the agent is worried about, right? You have end-to-end latency, right from when I click the button or I ask for a request, how long does it take for the agent to complete its trace or its task? Then the total cost per task, right? So if I'm calling, agent X, and agent X does 200 calls over its span, how much does that cost me? So, that could be, if you're paying on a kind of per token basis, that can be per token, or if you have your own infrastructure, you kind of, you work out that number by your kind of total cost of ownership. And the third thing is the accuracy of the agent, right? So, if I'm running a insurance validation of a claim workflow. We're working with some of our clients who are doing similar things. This is really important. So, how accurate was that agent in completing its task, in terms of getting the claims right, calling the right tools and things like that. So those are the key things. Now, what you've kind of got here is what happens very quickly in terms of the number of tokens scaling very fast, right? So you've got the user request, maybe call one, you've got a plan, and then you've got the tool calls, right? And managing context is a huge part of this, right? How do we make sure we manage context of our agents? So if you kind of think about what is going on in the under the hood of a planner and what matters for inference providers, it's basically the fact that you want to make sure that you've got profitable margins, flexible infrastructure, and it's energy efficient, right? So here, what we've got is something what we kind of call, an agentic planner. You may have coding, embedding, something task specific, and then you've got a final output as well. And what you are tasked with is that you have an unpredictable workload. And this can be challenging for, cloud providers or end users, right? Like, how do you make sure that if you are managing a budget for your team in terms of compute cost, how do you make sure that you manage it properly and that you basically map the workloads of your agents? So here at SambaNova, what we've done is we've launched a new chip, which we called the SM50, and a new rack, which, the Samba Rack SM50, which we're shipping in Q4. Now, so what we're saying here is that we have a system built custom to run these large models that gives you kind of fast mode in these frontier models at a fraction of the cost. So before I kind of go into the kind of the underlying bits of the chip and stuff like that, what I will kind of want to show you is how that kind of looks in practice, right? So here we're using one of our apps at the moment. So we've got a few apps here. So here is kind of one of our apps that we're kind of going to call Samba Chat, right? And this is a fork of one of the popular chat apps that we've done some stuff to. We've included our own runtime, and we've done some stuff under the hood to kind of make it run as we want it to, and also run on-prem as well. So what we can do here is I'm going to just try and find, so what I'm going to do here is I'm going to try and basically run something. So what we've got here is I'm going to basically put our code interpreter in, and then what I'm going to do is I'm going to include this data set. So what we're doing here, and what I'm using is Minimax 2.5. And again, we've got this code so you can actually kind of deploy this yourself with Helm charts. But what I really want to show you is what that difference means when you actually run it. So this is Minimax running a totally kind of autonomous data analysis pipeline. And the bit I'm kind of trying to show you is the speed that it's able to run at, right? So we're able to have kind of reasoning, code generation, execution, all running really, really quickly. And one of the things that, again, we think is really important here is that a lot of the speed that you're seeing comes from different places, right? So you've got the infrastructure on the CPU side, you've got how fast is your sandbox, how fast is your web search, and things like that. But what we've got here is basically Minimax doing all of this. So what I fed it was basically like a kind of mini Kaggle competition, right? I gave it a data set, and I've said to it, go and find me the best model. I guess, those of us who started from data science, the stuff that you used to do manually using pandas and stuff. And I basically told it to go ahead and write a report, right? So basically, in less than 2 minutes, Minimax has done all of those calls. It's generated a ton of tokens, and it's giving me the output. Now, again, why I think this is super important is because as you scale agents, there's two things that you really care about. As I said, end-to-end latency and how fast the agent can work. And what we do here at SambaNova is that we make sure that our token speeds are high so that when you chain these agentic calls, you can actually run coding agents a lot faster than we see on GPUs and things like that. And a lot of our clients have been coming to us. But we kind of wanted to show you what that means in real life. So here, this is kind of generated a report. So if I click here, so you can see here that it's gone through and it's kind of done that EDA. It's generated the artifacts. And again, a very great report, and 8 pages, and it's done all of that in kind of less than a minute and a half. And the key unlock here is actually having inference that is super fast, right? So one of the key reasons that we talk about the difference that fast inference makes in real life is that when you run thousands of these agentic workflows, so say that I've got a coding agent that's running autonomously, I have an analytics agent, or I've got an agent that's doing visual analysis and things like that. Having these calls come back quickly makes a real big difference from compressing a workflow that maybe took, say, 30-40 minutes to something that could take 7 or 8 minutes. And that's a huge unlock in terms of intelligence, because intelligence is really measured on how fast the model can think, right? Because it can generate more reasoning tokens. So I just kind of wanted to give you a flavor of what this means like in real life. And again, we've got these reference architectures. This is what me and my team work on. So you can go and deploy this on your own infrastructure and try it with SambaNova yourself. So I'm going to go back to this to kind of set the scene and kind of go through that. But before, I'm going to kind of stop to see if there's any questions. I can't see any questions at the moment, so I'm just going to continue. So what we're kind of giving here is kind of a snapshot of what the SM50 allows us to do. So again, we've got the hardware features. We've increased the compute from our previous chip. We've increased the network bandwidth. Also with the throughput as well, and also we have this thing called agentic caching, which I'll show you very quickly, and then we've also got this thing called cloud scale as well. So what's really cool here is that if you kind of go into our next slide, this is the bit that we think is really important for agents moving forward, and in general where we think compute is going. And we've had this validated by what happened at GTC and the recent acquisitions and things like that. Now the general consensus is that there's things that GPUs are really good at, and there's things that other custom providers are really good at, but they both have their drawbacks in terms of how latency and then scalability. So if you start on the the furthest left hand side, what you've got here is kind of the GPU B200s we're using here, and of course they are very good at batching requests. So you can imagine that if I'm trying to batch a ton of loss adjustment and I want to process that, great. If I have a no latency budget, you can batch all those requests together, and CPUs are very good at that. They have very high batch sizes. However, what that means is if you are running an app that is interactive with a user, like lots of agents are, your latency is not going to be acceptable to the user, right? You're going to kind of go down to this kind of 40 to 60 to 70 tokens per second, which in modern day AI is going to start to look really slow, and a user will come kind of disenfranchised, right? Now, what you've got on the furthest right-hand side is you've got the super fast, right? So you may have a provider who can get very fast inference speeds, so like Cerebras, for instance. But the problem here is that the scale is very hard, right? So what I've got here is that if I want to scale that to, let's say, to support 1,000 users and get the throughput up, I need to drastically scale the amount of infrastructure that I've got in order to support it. So you have these kind of two extremes where you have one where I can have super great batching, but I don't get the latency budget that is needed for agentic applications. And then on the other side, I get the latency budget, what's needed, but I need to basically scale my hardware a lot to get to the kind of throughput that I need to. So what we've kind of said here for ourselves is we have something what we kind of call the Goldilocks zone. So the Goldilocks zone for us is basically where we have a acceptable amount of tokens per user. So essentially we can keep the throughput so much that a user is seeing around 300, 400 tokens per second. However, we're able to do that on a much smaller hardware footprint, which means that it's much more scalable. So you can scale it to many more users without having to scale, a huge amount of nodes to support it. So that's what we start to think is going to happen with agentic inference. And you're already seeing a lot of that in the market, right? You're seeing systems that are being built to kind of do disaggregated inference, and disaggregated inference is basically the idea of doing the prefill on say a GPU and then doing the decode on say like an RDU, which is our chip as well. So again, you're already seeing that serving workloads is starting to get specialized, and we think that our chip is really well placed. And based on where agents are going, we're seeing lots of need and people coming to us because they've tried to scale agents, but when they've tried to scale them to a, over 1,000, 10,000 users, they start to run into either this hardware problem or this latency problem. So again, this is the kind of the same chart, but here we're kind of using GPT OSS, and this was the models that I showed you. And you can see here that if the cost of getting to this tokens per second using a kind of normal just GPU approach is way basically we are far less expensive in order to get the same number of tokens and the same number of throughput. So that's really where you kind of get those savings, is the fact that, you've really got to scale the number of GPUs to get to that required kind of 600 tokens per second versus using the RDU architecture. So the next thing I'm kind of going to want to talk about, which I think is really important, especially for agentic models, is this thing that we're kind of calling agentic cache. So I'll jump into a demo to kind of show you a little bit what I mean by this and what actually happens. Okay, actually, I'm seeing all of the questions, sorry, coming through now. Sorry, I didn't actually, there was a Q&A button. So the reason of using token AI has processed. Do you offer an on-premise infrastructure solution? Yes, we do. It's called, so we basically our products you can have in the cloud, or we have something called Standard Stack where you can actually put this onto your own data center. So we do actually have that working as well. So hi, wondering what the stack for this code interpreter is. No, so the code interpreter. The code interpreter is basically us. So if you think about what a code interpreter is doing, it's basically just a runtime, right? So if it's basically just a runtime, which means it's some sort of x86 machine that is running. Now we actually built our own code interpreter runtime for security. We have customers who will actually not allow even their code to go to third-party providers who do sandboxes. So we have our own kind of sandbox runtime, which is isolated per user per thread. So it doesn't use LangChain or anything else. All we do is that we are using, in this instance, LangGraph to kind of orchestrate the agents. But all the sandbox is in terms of agents is a tool, right? So it's a tool, and that tool calls to the runtime, and we allow that runtime to expose very common sandbox tools like upload file, run code, all of that. But it's in a really trusted environment, and we destroy the sandboxes. Are ephemeral, like all sandboxes should be, and they persist for the thread. And then once that thread is done, the sandbox goes away. Okay, so I can rerun that code. I can tell you what it was doing. So basically that code that I shared, what it was basically doing analysis. It was doing EDA, and it was doing model selection like you would have done with like sklearn and things like that and pandas, but it was doing it all automatically. So it was going step by step, reasoning, finding out exactly what was happening, fixing its errors, and then coming up with a report. But I can, happy to go through it a little bit more. So is the Salmonova platform for building an AI factory? Will it be so? Yes. So basically, our platform is built to handle enterprise level, enterprise AI beyond agents as well, right? So if you want to build we expose OpenAI compatible endpoints. So what you do with those endpoints is completely up to you. Our customers do all sorts of things, but of course we see a huge shift in terms of agentic work. So that's kind of, one of the things that we support obviously as well. And the reason we talk about agents is because our hardware is made to work pretty well with agents, just because of the number of calls agents do and what that means there as well. Okay, so so I will talk about agentic caching now, and maybe I'll come back to that question there as well. What metric do you recommend to measure the unit cost for faster inference? So this is a good question. So what I would recommend is like how many tokens tokens generated per user, right? That's really what I want to that's really what I want to see here. How many tokens are generated per user? Because essentially that's the thing that a user sees. So if you're running inference, you can run inference super fast, but how many users can it support, right? So like what is the throughput per user, I think is a really good way of doing it. Okay, so I'm just going through some of these questions. I can review them as well. So Robert Wilcox, do you have a GitHub of the project you created for building models? So I don't quite understand the question for building models. So we have we use open source models, so we don't kind of build the models ourselves. But if you're talking about the app, yeah, we can share with you some of the GitHubs that we use there as well. So does the SM50 get provisions through one of the cloud providers? No, no. So we are actually working with some of the cloud providers as well. So we are basically we're making it easy so that you can use our compute, but through your existing cloud infrastructure. So we're working on that, and so hang tight on that. We're making some good progress there. Okay, thank you for all the questions. I'm going to kind of go back to this, and I'll return to the questions in a sec. Okay, agentic caching. So what is agentic caching? So there's two things you should think about, right, when you're doing your agentic workflow. So one of them is the fact that if you call an agentic flow, it's likely that I'm using more than one model, right? So I may use a model for the planner, I may have a specific audio model, maybe a multimodal model, but I have different models, right? Now, what that means usually on a GPU infrastructure is that I need to stand up a different node to serve each of the models. Now, you can, of course, load and unload different models on a GPU, but the time to do it is very big. And so what we call agentic caching is the fact that because of our 3-tier memory, we have a lot of kind of this off-chip memory that we can actually, this DDR, that we can actually use, and HBM, that we can actually use to host these models and swap them in super fast. And why that's important is it means, again, the whole point here is scaling the kind of infrastructure crisis, right? So if I can collapse the footprint of my model or my models onto a smaller hardware footprint, it means that I can use them quicker, and I don't have to, again, I can get more kind of inference for my buck because I can swap models really fast. Now, what we're saying here, so we take a Llama 70B, right? So obviously GPU uncached 8 seconds, it's likely that you'll have the model at least cached. So if we compare cached to the SM40, SM50, you can see that there's a huge difference, right? 0.2 seconds to 1.5 seconds. Now, why this becomes super important is if I'm doing agentic workflows and I want to swap models, then having a slower model swapping time, that will compound. So in that workflow that I just showed you, you can imagine that if I was changing to loads of different models, I would have like 1.5 seconds added, and that would over 70 calls across 5 or 6 models, that would really start to add up. And on the Llama 8B, again, you see it not quite as pronounced because it's a smaller model. But the biggest one, I think, is when, we're one of the few providers that runs DeepSeek, the current DeepSeeks at their full quantization, so like full precision. So when we swap it on the SM40, SM50 on the cache, it's 0.5 seconds, whereas a GPU is 6 seconds. So this is where you start to see a real big increase in terms of model switching time. And by being able to swap models quickly, we can run workflows super quickly as well. So what I'm going to do now is kind of show you what I mean by that. So I'm just going to go to, okay, so we're going to, let me see here. Oh, so I think my screen sharing just stopped. I'm not sure why. Give me 2 seconds and I'll see. Try and find out what happened there. Okay. Okay. So I think we've got it back. So I'm just going to share my screen again. Apologies about that. Okay. So What we've got here is kind of, again, another application. So what I'm going to do here is, actually, I'm going to see if I can, okay, share some sound here. Okay, perfect. So what I'm going to do now is ask a question. So I'm going to say something like, I don't know, analyze Apple's financials for me. So the reason I'm running this is I want to kind of show you, and this is another app that we made. Again, we have this code. It's called Agents, and it's on chat.salmonova.ai. And me and my team, we do many things. So this on the right hand side, you're seeing a load of agents run, right? So we have a risk assessment agent, we have a fundamentals agent. And what's really cool about this is that what I'm trying to show you is what that model swapping means. So we use three different models here. We had Minimax, we had 3.370B, and we had Llama Maverick, right? And they all made different levels of calls. Now, what we mean by swapping the hot swapping of the models and the agentic cache is that you can actually run all of this on one node, which then means that you can basically run this on the same infrastructure versus having to swap to a different node. Now, the reason why I think that's important is I'm going to kind of show you underneath what's happening here. So you can see here, Minimax started, right? Then we switched to 3.3. Then you can see 3.3, some parallel tool calls. And then finally, I used Maverick to do some, news and aggregation. So you can see here what happens when you're actually switching out. And these kind of little milliseconds, once you compound them over thousands of tool calls and thousands of users and traces, the difference is significant. And so that's why we always want to kind of get people. That's the easiest way I can show you, is kind of showing you what happens behind the hood of these models being called, and just the fact that we're able to switch them in super fast, and it makes a huge difference. So again, this is a nice way of looking at that kind of model swapping and agentic cache side of things. Okay, so let me go back to this. So again, a little bit more about the chips. So we're able to scale over kind of 256 accelerators, so that you kind of multi-terabyte per second interconnect with its proprietary, but you can kind of scale up to kind of 10 trillion parameter models, right? And huge context lengths as well. So we all know that context length is another big differentiator. We know that Opus is a 1 million context, and that is a big advantage. And I think Gemini, when it did have the longest context, it was a huge deciding factor for many people who needed that long context as well. So again, this is kind of a product comparison summary. What we've got here is where we think the SM40 is, which is what the chip that we have now, and that's the chip that these demos are running against. The SM50 will be significantly faster, and with only a little bit increased in the power efficiency. So for those of you who kind of get into the hardware, we run our SM40s at around 10 to 12 kilowatts, which is compared to the equivalent GPU, which is around 120 kilowatts. So it's an order of magnitude saving in terms of power. And then the SM50, I think, will be around 25 kilowatts as well. And what we've got here, again, we're very good at running the big models, and we think that our power efficiency is pretty good. But again, this is what I was trying to show you with the differences with the other providers, is that they're good at some things. Cerebra's are excellent at inference speed, but they fall down in other places like power efficiency and tokens. Power efficiency in terms of high tokens per watt, and then power efficiency, low kilowatt per rack, and agentic caching, and the ability to swap those models in as well. So again, this is like a nice comparison to kind of give you an idea of where we think we play well. And again, what I also want to be clear here is that there are some workloads. If all that you are optimizing for is speed and you don't care about efficiency, then we might not be the right provider for you, right? Like if you need ultra fast, but you're willing to build billions and billions in data centers, then that's another thing. And of course, if batching is what you're doing and throughput, and that's the key metric for you, and you're not latency sensitive, then on that other side of the graph might be good. But what we're seeing with this agentic push is that we really see lots of people needing both the speed and the throughput to serve their users. So just a little bit about, I guess, who the folks that we're working with. We have three products, as I said: Samba Managed and Samba Stack and Samba Cloud. So we have a sovereign AI play. So we have a lot of sovereign AI at the moment. This is where people take our racks. They either use our cloud, and we kind of, they have a white label. We work with Neo Clouds who are using us, and then so these are all the people that it's for, and it's designed for those companies who need to scale up their inference super quickly and need to get it at the fastest speeds. So with that, I'm just looking at time. So I just want to make sure that I leave time for questions. I haven't gone into some of the questions, so let me go and do that. Let me see. So let me just go into the questions, and again, here we go. Q&A. Okay, okay, let's have a look. So there's a lot of questions here. Okay, so which GPU is it? Is it NVIDIA or an AMD? No, so it's actually we make our own chips. So it's an RDU. So Samba Nova, if you look here, this is our own custom chip. It's our own custom silicon. So we are an alternative to GPU. So we think that we have very, very compelling inference speeds. And so we have our own custom silicon, our own runtime, our own compiler. So we don't use GPUs. Okay, so can you share a little bit more about the platform? But platform support for agents, MC, or about security. So we basically concentrate on the hardware side of things. We have lots of integrations into all of these platforms like LangFuse, all the observability, all the MCP, all the platforms like ADK, LangGraph, all of these things. Now, me and my team, we build reference architecture, so we can share those links with you. And a lot of the demos that I showed you, we actually just share them. We show our customers how to use the platforms, so that's how we support through integrations and things like that. But we ourselves we're not a solutions company. We give you reference architecture that we think that you can use on our software and hardware. Okay, someone's already answered the question. When hot swapping models, how does concurrent requests from different users work? Yeah, are they queued? That's a great question. Yeah, they are. So we have some kind of work in the background that's working with the queue like a router, and then they will, based on the algorithm, we will swap and make sure that they get put into the best queue for them. So that's the thing. We make sure that request goes to, of course, it will go to a model, right? So we make sure it goes to the best node that we think can serve that traffic as well. Yeah. So how to decide which model to use first and which to switch over time. So I think this is really interesting, right? So I think, if you go for kind of an example, you should be able to. I like to think of this. If you're doing reasoning tasks, then you want the stronger models, right? So like if you're doing, I can give you an example of this actually. Maybe it's easier if I just go back to here, right? So I'm gonna go into full screen here. So, I'm not in full screen. I thought I was. Okay, so I think everyone can see my screen. So the question here is, how do we, when do you know which one to use? So let me see if I can do this. So when do you know which one to use? It very much depends on the task, right? So if you're doing something that's reasoning heavy, I would always recommend that you use your reasoning model, and then for the smaller tasks, you can then pass it off to another model. So for instance, if I write something like so I think we have, yeah. So can you get me the latest stories in AI as at April 2026 and create a PDF with stories and source links. So in something like this, when I hit go, where the model that first does this, that routes needs to be your most powerful model, right? So you need to have a model that's super powerful to kind of do all the routing. Now, the stuff that happens underneath it, like maybe your coding model, maybe the one that's doing the actual, what's it called? Maybe the one that's doing the actual like web search doesn't need to be as powerful, right? Because it has a very clear task. You can set it off as a sub agent and you don't need to waste tokens there or have an expensive thing. So again, I think my general rule is the more reasoning heavy or the planners, more, more parameters, more intelligence, but the more task specific, you can come down to smaller parameter sizes and more specialist models as well. Okay, I hope that helped. So what breaks first when agent workloads scale, latency, cost, or accuracy? I'll be honest, I think the two that break the first, given that the quality of models that we've got are latency and cost. And these are the things that we're trying to solve for at SandBanova, right? So you basically, if you try and scale, then and you want all the intelligence, you just have to wait. It just takes a long time. That's why, fast mode was developed in the first place, and why, the acquisition of NVIDIA and Grok made sense. They knew that they needed something to get the latency right. That's the first thing. Now, then the next thing that breaks after that, once you fix the latency, is the cost, right? Because you fix the latency, but at what cost? Like, do I have to now scale up to 70 nodes, right? Because I need to get that tokens per second that I showed on that graph. So that's how I think it breaks. Accuracy, I think, definitely, depending on the model and the guardrails, of course, accuracy is always a problem, but we're starting to get so good, and especially in certain domains with the accuracy. If you've got good architecture and you've got good, you're able to basically have the model, have guardrails, and be well trained and well directed. But for me, the two that break first are latency and cost, for sure. So inference economics, how do you measure the real cost per agent task across many tool calls? So I guess that's not simple. Again, if you use an observability platform, we're kind of open source. We use LangFuse. Or again, Langsmith, they've got one as well from LangChain. There's many of them out there, right? You can see in the back end, if you're on a per token basis, you can see how many tokens you have. But also, if you're running any tool calls, you just have to kind of do some napkin math, right? So if it's a managed service, how much does that managed service cost you, and what's the API cost there? If it's more like infrastructure, right? So for instance, we have to run our own sandboxes for private stuff, and if you're a client, you'd have to do that. So you have to think about the cost of the infrastructure as well. But I think first thing, model costs plus, API costs for tool calls, then plus the cost of the infrastructure that's running those tool calls. So if you're running a RAG database, you might have to spin up an EC2 to put Postgres on it, things as well. So that's, again, some good pointers for that as well. So why does high tokens per second matter so much for agentic workflows? Very good question, right? So it matters so much because you're doing so many calls. So if you think about it, when we first started LLMs, you used to do like one call, like, hello, how are you? Like, go and do this for me, and you just come back. It wasn't, yes, you could deal with a speed decrease, but it wasn't such a huge thing. But now, as I've shown you in these examples, in those examples, I did in the one that did the Netflix data set, there were probably about 35 LLM calls in there. So if you think about that, once that compounds, it gets really slow. So the tokens per second really start to matter, because it means that if that workflow was taking me 10, 12 minutes on a GPU, which we see normally, it means that I can collapse that down to like 1 to 2 minutes. And that's an order of magnitude faster in terms of getting that and getting your work done faster. So that's why we think it's important. It's important because there's more tokens are being generated for a start because of the reasoning, and secondly, you're doing more LLM calls. Okay. How does your cache reduce model switching time in multi-agent systems? So I think I kind of went through this. So basically, our cache supports it by, if we have low switching times, which means that if you have a multi-agent system, like I just showed you, because we have this kind of agentic cache, we can swap out models in like milliseconds, which means that it doesn't impact your total end-to-end latency by a lot. So that's the cache system. And I'm happy to go more into it, but that essentially the nuts and bolts is we've got 3-tier memory. We can move the models very quickly between that 3-tier memory, which allows us to reduce the switching time. Okay, so how do you support thousands of concurrent agentic users without huge infrastructure growth? So again, the answer here is kind of the answer to a couple of the last ones. So that I can swap models very quickly. That's the big one. So I can keep the throughput of the. So if I go back to this and I go into slideshow mode, let's go back to this to answer that question. Oh, it was this graph, I think. Yeah. So I can basically, in order to do that, the reason I can do it is that I can serve the user at a higher tokens per second and a lower infrastructure footprint. So that means that in order for me to scale, I have to scale less because I can support more in terms of the throughput. And this is the big SN50 unlock. So I'm happy to go more into it, but that is really the unlock there is the fact that because I can keep the infrastructure cost compacted because I have high tokens and low power and agentic cache, I then should be able to scale out more as well. Okay, so so I think there was a specific question there. Okay, I think I've kind of okay, maybe some more. So architecture. What is the difference between GPU batching and our RDU approach? So I think, I don't think there's too much of a difference in the batching. It's more about the hardware approach, right? So I think it's just more that we can basically, the GPU is very good at batching, right? But as I said, the problem that you've got there is that the latency goes down. So it's not so much the approach that we're talking about. It's just the fact that we think that we can run at a high enough batch size for you to have some really good tokens per second per user. That's the key difference, yeah. But again, happy to get into that a bit more. So you asking about use cases. So, okay, so this is a good question. So where do we see people using Samba override? So I'll give you a couple of examples. If you are latency sensitive, then people use Samba Nova. So we work with a company called Hume. They're a voice provider. They run their models on our RDU because we have super low latency. So that's an example. If you have a latency critical budget, then we're very good for tokens. Now, the other thing is that if you and many data center providers come to us because they have data center space, but they don't have this crazy power. Like they can't support these crazy power needs of some of these more power hungry systems, right? Over 120, 130 kilowatts per rack. So they say, hey, we've got this space, we want to run compute, but we don't have a lot of power. So that's another real reason that people come to us. That's a good use case from the hardware. Now, in terms of, where we see real big use cases, code generation, right? So, code generation is a huge case. I just showed you an example. We integrate with some of the big open source tools like OpenCode, and you can use Minimax and kind of get a very, very excellent coding experience at the fraction of the cost. So like that is a huge unlock, right? So like we're starting to see people say, hey, like this is a huge unlock from our point of view, and it allows us to basically run more either run more complex agentic workflows quicker, one thing, or I can run more of them, right? I can support more users. So coding is really taking off. But to answer your question, if your voice or latency sensitive, if you haven't got power, and the last one I should say is security. So someone asked at the top of the meeting, can you bring the racks on premises? Some of our key customers, we work with some of the national labs in the United States. They of course are very security conscious. All the racks are, like on-prem, right? So if you're security conscious, you can't have your data leaving, then again, we're a really good fit, right? Because everything that I've showed you can be delivered onto a data center premises or a co-location and things like that. So we think those are the things where those are the areas where we see a natural fit for Samba Nova. Okay, so the PDF was lightning fast. Yeah, I'm sure we can give you we can kind of share the repo for this. Does it? So follow-up Bayesian, does it choose the models autonomously? No. So basically good question there. You can have routers, by the way, that say, hey, this looks like query, this looks like this kind of query, route it to that model. So you could do things like that. But what I'm finding is, again, for me, I think people kind of know pretty well when they design an agentic application, what model they want to use for what time. But you can also put routers in. But for this example, I chose it. It was predetermined. I specifically chose those models because, again, I want to mix up my more powerful models to do the reasoning to my cheaper models or my smaller models to do more of the kind of task heavy work. I don't need like DeepSeek 671 to go and do a web search, right? I can use like a Llama 8 or Llama 8 70B model, far quicker, far cheaper, far more efficient as well. But you can put routers in and stuff if you want to do that. Okay, so what are your thoughts on context caching? So um, that's a whole other what's it called, subject in terms of that. That's kind of like prompt caching and things like that. So we currently are working on prompt caching, as a lot of people are, but this is something that's, again, something that we're working on. But it's, again, this is something that we'll look to kind of get into the platform at in the future as well. But it will make a big difference, especially to coding solutions and things like that. Um, okay, so I think I've answered most of the questions there. I think we're coming up to time. So I'm gonna get out of here and then try and stop sharing my screen. Okay. So yeah, I think that was it. Sorry, I think I've been going. I think it's 12
Yeah,
o'clock, so
no,
we've
for
come to the
sure.
end.
Thank you
Yeah,
so much. Yeah,
yeah.
no, thank you for walking through, the Salmonova platform, going through all the details as well, answering our audience questions. It was very, very productive. So yeah, appreciate you going through that, Kwasi. And we will take like a 9-minute break before our next session. So yeah, go grab a coffee, stretch your legs, whatever you need, and then we'll be back shortly in 9 minutes for our next item.
Thanks.
Hey, welcome back. So this tutorial, we're going to focus on why AI projects fail. Really important topic. So war stories from real customer deployment. So Raja Iqbal is going to be taking you through this incredibly important lesson on where things tend to go wrong. And this especially tends to happen at the point of when you go to deploy in the real world. So we'll look at how, failure happens and some steps organizations can take to avoid failure. So I'll hand it over to Raja to start the tutorial.
Thank you, Rebecca. I will get situated properly, all my screens and everything, and the chat window. Okay, we are all set. And one last thing, I have to start sharing my screen. Okay, and my screen should also be visible now. Okay, we are all set. Welcome, everyone. You have seen me yesterday in case you attended some of the panels. Here I am, back here. And what I'm going to talk about is essentially what we have observed, the patterns we have observed while talking to some of our customers on the training side, on the upskilling side, and also on the product side. So we have been talking to a lot of customers, training a lot of customers, building solutions for a lot of customers, and deploying a product that we have built within a lot of customers' own cloud. I don't think I formally introduced myself, so here I am. Feel free to connect with me on LinkedIn. You can look me up, and the QR code is there. I've been practicing AI for more than half of my life. A long time ago, started in grad school, ended up doing machine learning. Worked for Microsoft a bit. Most of my time was at Bing and Bing Ads. And currently, I am the founder of Agentic AI. I'm also an instructor for Data Science Dojo, and I am also an adjunct faculty at the University of Pittsburgh. I teach generative AI, a grad level course and an undergraduate course. Let's dive right in. So when companies they start investing in AI, when they start building AI products, there is this core paradox. And what is that core paradox? Pretty much every company is investing in AI right now. I mean, any company that matters, everyone is rushing to so that they are not left behind. Companies that launch pilots. Pilots are launched. And at an individual level, for a customer, they or maybe not a customer, but actually at an employee level, or maybe at a small team level, the pilot shows success. There is some individual gain that is visible, and they try to deploy these pilots. But what ends up happening is that when these pilots are deployed widely, and I can give you examples firsthand that we have seen a sales co-pilot deployed that the sales team does not want to use. You have some marketing CRM type tool deployed as companion to CRMs. CRMs are already there, but a companion to CRM deployed, but no one wants to use it, right? So, and there are a lot of different reasons that we will talk about, but fundamentally what happens is companies, they do adopt, they at least try to adopt on surface, they try to adopt AI, but they don't change their operating model. And they don't adapt their standard workflows. And the gains that apparently are visible at an individual or very small team level, these gains are not visible on the balance sheet. And as AI, the case that we'll make is that AI, and especially agentic AI, it requires your enterprise to be fundamentally rewired. You have to do certain things differently. You have to start to do certain things differently when you are in that AI transformation journey. And very often, in this case, the bottleneck is usually not model quality or data availability. Models are amazing, right? So having built these systems in the last couple of years, I can tell you the models have come a long, long way. It is incredible how models are, the innovation has accelerated on the model side and even the architecture side, token limits, inference, the latencies in terms of, context windows have improved. Reasoning has incredibly improved. A lot of things that we had to prompt for now, you don't have to, right? So it's part of the reasoning architecture. And usually the challenges that the organizations are now facing are not really the technical capability only. It is the technical capability not able to meet the organizational design. It is the last mile problem, as we call it. So here is this idea that there are these islands of productivity. I have this tool. I can write proposals very well on my laptop, or perhaps one or two people. But there is, when I try to scale these pilots widely, things don't work. Things don't work as well. Uh, Perhaps you have this example here. It is the bottleneck that is shifting. Previously, you were spending more time in drafting this complex contract, but now there is a manual legal review that has to happen, and that manual legal review is, well, it is still the bottleneck, right? So you have automated part of your contract pipeline, but you have not fundamentally designed the entire workflow to move at an agentic pace. Also, there is what we have observed is that companies usually they start at the top. Companies would start scaling agents right away. Just let's go and build this agent, only to realize that their infrastructure, their tools, data and tools are not ready. You may not have the right connectors. You don't have the right access. That you don't have the right permissions, and the processes are not there. Then you have the security, privacy, and compliance and governance problems that are a big challenge. Then you have this interoperability problem, right? So do the data sources and agents, can they talk to each other? And just talking is not enough. Talking in a manner that it is safe, right? So do they talk in a compliant manner? Do they talk in a are they maintaining the governance aspect of it, and so on? Then there is the general literacy in your organization, which is I will mention in a later slide. It is an underappreciated area. More so, it is incredibly important, more important than ever, that your entire organization is AI upskilled. And you will, if you are a decision maker, you will have tons of people who will come to you, service providers and solution integrators and services companies. They will come and say, "Hey, we will just come and deploy things for you," right? So we'll just come in, and it's going to be roses, and it is going to be happy, or you will live happily ever after. But the challenge is, it doesn't work that way. It doesn't work that way because the details are actually quite gory. We'll look at what there are. So first, we will look at some key friction points. By the way, this is not primarily a technical talk. This is maybe for a change. I think most of our talks have been technical, but this is going to be less of a technical talk and more on the other non-technical aspects of that are needed for success. So we'll discuss some canonical friction, organizational friction points. And these are not technology gaps. I'm not going to fret about technology in this talk. I'm going to talk about really the organizational design aspect of AI adoption. As I said, structural barriers within an organization. And what my hope is, by the end of this talk, all of you will be in a position to at least assess where the company stands and what your AI transformation roadmap must address. We'll talk about these 7 points. The first one, what we call the pilot proliferation. There is this thing called productivity gap. There is a process. There's this thing called process debt. Then governance is there. Architectural complexity is there. The efficiency trap and the tribal knowledge is there. So the first one. So I like this the way some of these ideas are coming from an article. So I like the way the authors actually talk about this. That this is they call it pilot rich and transformation poor, right? So and if you look at it, this is the reality of many companies at the moment, but the problem is that many cases there is no repeatable path, and each pilot remains in an island. And the question that you should be asking in your organization is, this proposal writer that I have built, or this maybe CRM automation agent that I have written, or this automated email responder that we have created, or this automated legal document review, or this maybe AI paralegal that we have created. What is the repeatable path from this working pilot to the point that this becomes a standard company workflow? The next thing that you need to ask is, how would these individual gains, the respective gains that you achieve in respective areas, how do they show up in your balance sheet? And worse, right? So there's a worse, something that is worse. I don't know how many of you have heard of this term called AI slop. I mean, they used to call it work slop. Now they say AI slop. Basically, instead of AI helping, now there is this AI slop being created, and now you're spending more time fixing the problems left by either a sloppy AI agent or a sloppy use of an AI agent by someone who is not done their job, right? So, so how do you handle with this, right? So, but this is the best case scenario. Let's say you have a productive agent that actually saves you time. How is that time going to be reabsorbed? Because what we have seen is, basically, worst case scenario is that AI, instead of helping, there is an illusion of AI helping in productivity, whereas AI is actually creating more work than actually helping. So the question, even if it is a successful Copilot, is where specifically would the reclaimed time go at your company? And who owns that redesign? Okay. Sorry. Here and process debt. Broken processes, they cannot be redesigned. They need a rebuild. And for those of you who have been building or have been working in data and analytics for a while now, we saw the same thing when we were going through this, the previous wave of predictive modeling and machine learning and data science or analytics transformation, that, well, garbage in, garbage out, as we call it, right? So if your data is broken, how do you can you build models on it? In this case, if your processes are broken, if your data quality is bad, data is still the king. How do you redesign your processes from scratch so AI can run on them reliably? Does everyone know how to use this AI agent? Because this end-to-end automation, it is easier said than done. In the AMD demo that we were looking at, this whole open claw thing, it comes with a disclaimer. Someone was telling me just yesterday, I think one of the speakers, or I'm forgetting who told me, but OpenClaw actually modified its own guardrails. It found it to be restricting because when you give autonomy to these tools, well, they are autonomous. The blessing in these tools is the autonomy, and the curse is also that can also become the curse. And how do you make sure that your process is redesigned such that it is AI ready, and which workflows you need to rebuild before we can layer AI on top, and for that matter, which workflows can be used as is. This is a good one. Now, when we look at AI, that's called GPT 5.2, GPT 5.1, Llama 4, Claude Sonnet, Claude Opus, right? So you name any model and tell me. These models are incredibly knowledgeable. They have seen a lot of data across the board, probably all the books that are published, the entire internet, all the tweets, all of Reddit data. You just use your imagination. But one piece of knowledge or one aspect of knowledge that these models do not have is your organizational knowledge, right? So your whatever is inside your organization, because they don't have access to it. Well, when you build a retrieval augmented generation application, or when you build these data sources and or you connect these data sources with your models, well, you bridge that gap as well. Now, these models can now see your internal enterprise or your confidential or your proprietary knowledge as well. But there is still a piece of knowledge that these models do not have, which is what is sitting in my head. I never documented it, right? I'm a factory worker. When this machine vibrates, I have to kick it, right? And it starts working. I've not documented it, right? Or you know how when the remote starts working, when you just tap it, right? So one of those things, when this machine starts making noise, hey, unplug it and plug it back. And some of these, and these are extreme examples, but there is a lot of organizational wisdom. This is that 30, 40-year-old factory plant worker. This is your receptionist who has been there for 20 years. And they have all of this in their head. How would AI know it? It's not documented. There's no MCP for scooping out that knowledge. We don't have that neural link yet. How do you scoop out that knowledge from this experienced worker? Call it the wisdom part of it, right? So AI is very intelligent, and the knowledge is there, but the wisdom is not. Let's call it wisdom. Where is that wisdom? So, well, you will have to get that documented. How do you get that documented? Because the moment you start talking about it, people, they will feel unsafe. So a key aspect of your organizational AI transformation design has to be that you have to reframe knowledge capture more as, well, legacy building, improving things, as opposed to being a threat to, not a cost-cutting exercise. Because the moment we frame it as a cost-cutting exercise, well, it is you will start seeing that defensive behavior and lack of cooperation. I'm talking about witnessing this in organizations where we help them build perfectly fine, very good AI assistants, but adoption was hard for one reason or the other, and this is one of the reasons that was observed. Then another aspect, and there is a QR code. Feel free to actually scan the QR code. There is a link to this article that actually addresses this. There is this aspect of governance. Going back to the OpenClaw example, autonomy. If you give autonomy to systems that are non-deterministic, they're very powerful. They can reason on their own. And I'm sure the fact that you guys are here, you are interested, you must have seen some of those news that some Replit agent or lovable agent going and deleting a production database, right? So we have seen some of those. By design, these tools are meant to be autonomous, which makes them very powerful. What kind of governance framework do you have on top of it? What roles and what permissions these agents or these systems should have for them to be able to take actions? And when you build these systems, when you start looking at these systems are fairly complex. When I go and use an assistant, it is not necessarily a single large language model call. It's not a single LLM call. There is a lot that happens, and maybe 10, 20, 30 LLM calls that are happening. Think about this, that a task that is given to apparently a single agent, there is sub-agents that are running. How much of can human in the loop even be an option there? Can human in the loop even exist in this case? So the question is, how do you assign permissions to these? How do you assign roles to these? How do you control access? This is going to be a challenge. So invest in AI governance framework earlier on, and understand what are your company's non-negotiable human approval gates as agentic workflows. So these things must be approved by a human, period. Because, for instance, right? So you cannot, your triage nurse can never write a prescription. Your AI triage nurse can never write a prescription because there are regulatory concerns. And now it is you, the business owner, who is going to be who will be in a better position to decide which of these human approval gates are non-negotiable. And in this case, organizations, they must treat agents like a managed workforce. Treat them like your employees. Give them permissions, onboard them, do a background check, monitor performance, make sure they're compliant, give them permissions for certain actions, and restrict them from certain actions. Don't let them actually don't give them permissions to elevate their own role or elevate their own access. Things like that. So treat them like you're a managed human workforce, and that will actually make a lot of things easier. Then there is, if you look at this, there is an enterprise architecture. Usually it is actually quite complex, right? So how do you, what connections and what interconnections must be in place before you can actually layer AI on top of your architecture? There is going to be your enterprise is changing constantly. How do you make sure that your platform evolution, it does not outpace? I mean, things don't change to the point that your initial assumptions are void. then I think this is once again that the same idea, the tribal knowledge part, the efficiency trap, frame this whole idea of AI adoption more not as a headcount reduction exercise, more frame this as a value creation and competitive advantage tool, not necessarily about headcount elimination. So how can your organization actually scale AI pilot successfully? So I will come back to this slide. I want to be mindful of the time we have. I promise I will come back if we have time. But let's very quickly go through a few things. The first and foremost thing is that you start with business first. And some of these things we just talked about, take a more business-centric approach. Do not actually assume that this is merely a technology problem. It's more than just a technology problem. Identify, what are the key KPIs? What is the needle that you need to move? Where are the opportunities, and what are the bottlenecks at that to realizing the potential of AI transformation? So we finished this part just now, but there is another aspect of it. Everything that we talked about, none of it is going to make sense unless your entire organization is upskilled. And when I talk about entire organization, I mean entire organization, every single person. And when you look at it, this is an underappreciated area, because most of the focus, even in analytics, even when we talk about the machine learning and predictive modeling, and I've been teaching for quite some time now, and majority of the people who attend these trainings, I would say significant majority is people who are builders, who are actually going to go and implement things. But there is no emphasis on the rest of the ecosystem, people who are the enablers of these products, the project managers, the program managers, the product managers, the people who will consume these products, the person who will create, you will manage your data, the person who's going to actually use this or deploy this in the field. So we look at it, if you look at this, usually companies focus on the AI capable tier. What I'm saying here is that we have to also focus on this AI aware tier, which is some very, very basic literacy. In case of AI and knowledge work, at least some very basic understanding of how to build, how to write effective prompts, how to get understanding of, if you phrase the question poorly, it is going to cost you more. If you just bring in a lot of context, Anthropic is going to be happy because they will send you a fat bill. But the reality is, you have to have people in your entire organization, every single person who is a good power user of these tools, being able to understand some basic concepts. How does not at the architecture level, but generally how are these tools actually working? So everyone is able to actually get the most out of these tools. So an awareness of possibilities and challenges that everyone should be aware as well. If I am a front desk associate and I'm working at the reception, how can I use it to make my job more efficient? If I'm a nurse, how can I do it? If I am a marketing manager, how do I do it? If I'm a developer, that one is the more obvious case, but you name it. Any knowledge worker should be able to should have at least a very basic understanding. Then there is this AI ready tier. where this portion of the workforce that can connect the opportunities in their own industry, in their own domain to AI. Well, if I saw someone doing an automated proposal writer, well, what does it mean in my case? If I see a legal document reviewer in legal industry, how can I use it in retail? So being able to connect those opportunities and engage with people in the AI capable tier to plan some widespread AI initiatives. So if you look at this, most of the people, they are in the bottom, the bottom tier. The bottom tier, and I see some questions coming up. I will pause after this slide to actually take those questions. And please type in your questions. I mean, they are coming up. So as I said, every single member in your organization must be AI literate. The builders, I don't need to emphasize, it's builders actually, they want to be very, very literate. I don't need to make a case there. But the ecosystem, people who are consuming or enabling, consuming and guiding, there is a typo here, right? So people who are consuming and building data and AI products, they have to be AI aware. I mean, so ideally, they have to be AI ready. Then leadership, they must be, right? So there's no other way, right? So I know actually someone very high up. I mean, I think CXO of a $1 billion+ company last week on-site meeting, and the guy actually started building using Claude Code, never coded in entire life ever. And the guy was so excited about being able to build a proof of concept for an application, and giving a tough time to the AI team because, well, started building. I mean, said, I mean, is it even possible? And yes, I mean, if you look at this, you're now from ideation to actually a proof of concept, it is quite easy. And now a lot is possible. And this was actually not possible until a few years ago. So let me actually take some of the questions. I will go back. Jane, your question: what role in an organization fit into the AI ready stage? It depends upon the organization. What I can tell you is AI ready is at least your product managers, your project managers, your program managers, people who are either involved in building products, not the hands-on part, but at least they're the ones who are guiding the products, right? So they must be AI ready. And I actually think that an AI product manager is going to be one of the most sought after roles. And this is based on me hiring a few people here and there, looking at customers, talking about what they need. And also based on our own products that we are building, we are I think that I mean, anyone who can think as with more customer empathy can be more product focused. Can envision, has an understanding of the business and the domain. And if they are AI ready, that's actually an amazing combination. So, but anyone right now who is actually helping the builders in a supporting role and think product, program, project manager type people, they have to be AI ready. I mean, there's no other way, in my opinion. Of course, I mean, depending upon what industry, what company you are, you may be able to survive. But if you want to be, if you're very, very obsessed or selfish about your career, you better be AI ready. Let me take, okay. Let me go from the top. A lot of questions. What is one practical change that most improves pilot to production conversion? Srinath, I mean, you got me. I don't know. I'm not sure if there's one practical change that most improves pilot to production conversion. That's a tough one. Basically, let me rephrase the question, and please feel free to type in if you think that this is, I'm rephrasing it correctly. You can say, what is the biggest reason the pilot to production conversion fails? Maybe let me flip it, because if we change it, then, it will be successful. Governance, I would say, because a lot of times the issues are around accidental exposure of data, accidental access, unauthorized access, accidentally not exposing any PII and all of that. I think that would be probably, if you gave me, hey, Raja, you can fix only one thing, I will fix governance. And this is assuming that the pilot from a technical standpoint is working well. If it is working well from a technical standpoint, I think governance is the first thing that I will fix. Thanks for forcing me to think and come up with a concrete answer. Let me see. Okay, this is scrolling very quickly. Okay, Jane, the question here is, do you think whether adopting agentic AI at an enterprise level will cause human resource redundancy? Jane, I think so. And this is something, and maybe at a very personal level, I can tell you, right? So I was just this morning, I was talking to a family member about my nephew, first year computer science, a freshman, or I think going into sophomore, after summer. And one piece of advice is, this is going to happen, right? So, and I'm not painting a doom and gloom scenario. But what is going to happen is people who are more of generalists, they're going to thrive and survive. So if I say, hey, I write beautiful code and I only write beautiful code, I don't know anything else, well, there is a lot of people who can do it. Anyone smart can write code now. But not everyone who's smart and can write code also has customer empathy. Not everyone can think in terms of what makes business sense. Not everyone can simplify things. So, some awesome, amazing content marketer, hey, I write beautiful blogs. Sorry, that boat has sailed. I mean, Claude and ChatGPT and these models, they can write beautiful blogs, but not everyone can think strategically in terms of marketing, right? So you cannot, who can execute the end-to-end marketing strategy? Who can actually not only use Claude to cut down their blog writing time by 80%, they still are good writers. They can still, massage it and, understand, what it takes to write a better blog. And they can also have a better content marketing plan. And also they can step in if there are other opportunities in marketing. So a lot of roles are going to, companies, they will need people who are multidimensional, who can do multiple things at the same time, right? These very specialized roles, especially in knowledge work, they are going to actually become quite difficult to actually retain. Okay, let me see. Maybe I will take one more question and then I'll come back. Let me see. Can agentic AI ever bridge the gap between external data and internal human knowledge? I think so. And that is a question, Mubin, you are asking this question. I think so, right? So when back in the day when I started working in online services right after my PhD, right? So I started working. I was fascinated by how granular the logging is becoming, right? So, at that time, maybe we logged all the activity in all what that would happen on the service, the search engine. Then you also are also bringing in logs from your app and joining them. Then you're also bringing in that, like think Google. You are gathering data from your search, but you're also gathering data from Chrome. You're also gathering data from Google Maps. You're also gathering data from your home automation, Google Home. Now you're bringing in more and more data sources. It is going to be only a matter of time. The point that I'm trying to make is when there is economic value in bringing in more data, the internal human knowledge organizations, they will start finding a way to extract that knowledge. Maybe every single meeting is going to be transcribed, right? We'll have every single interaction, which is already happening, by the way, in many places, but every single interaction that I'm having, it is going to be recorded. Maybe companies might come up with interview processes. Hey, how do you do this? Every time you do it, just talk it out loud. I don't know what that would look like, but that is going to happen because there is tremendous economic opportunity in scooping out that internal knowledge, right? And this is how we have evolved historically. Okay, I'll come back to some questions. Let me just finish this up. The third thing is, and going back to, I think there was a question around this, develop a more governance-centric view of your AI tools. And what that means is that think about this. A lot of times, when you go and use SaaS or when you use a third-party tool, maybe your industry does not. Maybe your industry, your regulation, you are in a country, I mean, you have to be, your cloud has to be sovereign. Or you are in healthcare, there are certain restrictions. Have proper auth and access controls for people using these agents and for agents accessing the actions and the sources of context. Have proper understanding and data governance and explanation of where all the data is, who has access, who does not have access. Observability. In the previous, if I may, let me call it the revolution, the predictive modeling and machine learning wave that happened, a lot of industries, they would say that they still want to use regression models because they are more explainable. And any model that was not explainable, like things like random forest or AdaBoost or XGBoost, they were not cool because, well, we cannot explain why certain things are happening the certain way. So having an observability layer on top of your infrastructure, that is going to be important. Then you have guardrails. Incredibly important. Guardrails are incredibly important because you may have implications if your chatbot or your assistant, if your assistant misfires, there can be a problem. Air Canada recently got sued by a passenger because the chatbot gave some information that was wrong. Matter went to court. Court ruled in favor of the customer, not Air Canada. evaluation. You have your models rely on sources of context, your data sources, organizational data is constantly shifting. How do you make sure that your assistants, they keep performing correctly and correctly and correctly? So there is a lot of things. I mean, if you have to take this organizational design or your, let's say, agentic AI organization, let's say you have a human org, and then you have your organization of AI agents. The way you do it, you are going to actually have similar concepts, similar ideas that you would be actually implementing. Okay, let me see what we have further here. So just how can we help as an organization, me, myself, Data Science Dojo or Agento? We actually are the first bootcamp in the world on agentic AI and large language models, and there are others that are popping up. We have been actually building, but we have been actually teaching. But the difference is we are not purely a training company. We are trainers who are also builders, right? So I'm one of the trainers myself. A lot of things that you hear are actually learned them the hard way. These are wounds and scars and scabs that I was mentioning. So I mean, if you're looking for a training program, we have training programs. I personally trained more than 8,000 people in a face-to-face setting. The company has trained a lot more than I have. Any company that matters on the planet, I mean, someone from that company has been trained by us. And we can also do upskilling, organizational upskilling, enterprise trainings at all levels. We have trained leadership, we have trained, the ecosystem, and then, of course, builder. We have trained a lot of builders actually from scratch. We have an AI product which actually mirrors the philosophy that I was mentioning, a product that treats your agents and agentic workflows as a human team with all the compliance and governance and other controls. And we not only provide the product and services, we also provide this advisory how to implement things in a manner that your AI products are successful. So the product that we have, as I said, right, so very quickly, it's a license product that it comes in and sits in your cloud. You can use any open source, any closed source LLM. Set up role-based access controls, so your agents, if they decide to go rogue, they don't have access to the wrong things. Then guardrails, observability, evaluation, AI red teaming is built in. Connect to any data. I mean, all the discussion that you were listening to, MCP actions and tools and security, observability, everything that you heard in the last couple of days. So the agenda was actually based on our experience as builders and our experience deploying these for our customers, as opposed to some topics that seem to be cool. And this is a complete platform. You can actually, once deployed, you can actually build there are APIs and you can build any application on top of it. We are GDPR, HIPAA, and SOC 2 compliant. And what we do is we take very similar approach. I mean, our slogan is IT is the new HR, right? So what that means is that there is a centralized management of AI coworkers for the entire life cycle, from the, call it hiring, use case identification, deployment, to agent learning and development, agent ops, observability, monitoring, feedback, cost monitoring, organizational alignment, and compliance. All of that is actually controlled centrally. And I will actually, so this is the link to contact us. If you think that we can be of any help to you in for your training, upskilling, or product or advisory needs, you can use this form. Just send us a note and we'll reach out to you. I will go back. I know I am right. It's right on top of hour. We are here. Let me just take, I will just take 2 more questions and then we will, I will hand it back to Rebecca. Yes, even if you are non-technical, we have trainings. I'm actually pretty confident, right? So I'm pretty confident that as long as you're committed, I mean, code is not even a problem anymore. So even if you're non-technical, you should be able to actually do it. And we have trainings actually for non-technical knowledge workers as well. So depending upon what you're looking for, we are going to, I mean, definitely, it should not be a problem. We have trainings for everyone, even our technical trainings. I think the way we have structured them, you should be able to actually keep up. Okay, what is the best way to manage accountability of quality of results and reliability of the pipeline, as there are a lot of under the hood dependencies? Take a more observability, evaluation, and governance first approach, right? So everything that you're talking about, you have to have all those controls in place before you even get started. Okay, and I think I will hand it back to Rebecca.
Sure. Well, thank you so much, Raja, for that, really useful discussion,
Thank
really
you.
important one too. And I really liked the point about, what about the wisdom sitting kind of exclusively inside a human's mind that's not specifically injected into a knowledge base for an AI agent. And, organizational wisdom often goes undocumented. So it's an important piece of missing data. And who knows, maybe in the future, it'll start to become more of a requirement for some documentation coming out of people's deeper thought process that goes into a task.
Or maybe a direct link, right? So just extract
who knows?
a neural link, right? So yeah.
Nothing's far-fetched. So we have about 7 minutes until our next session. So we'll take a short 7-minute break, and then we'll be back soon for the next session.
Okay. Thank you, Rebecca. Hi, Sher. We have a break until 1:10, so we'll be starting in about 6 minutes.
Awesome.
Okay, thank you. We'll be back just in a few moments. Okay, welcome back, everyone. And we have our next session. And the next session is going to be building distributed multi-agent systems using Google ADK and Cloud Run. And we have Sher Lador and Karthik with us from Google, and I will hand it over to them. Thank you so much, Sher.
Thank you so much, Raja, and thank you, Karthik, for joining us here today. Do we also have William and Pedro here, or were they not able to join? I cannot.
Yeah, we're here.
Great, great. Thank you so much for joining us. Do you want to say maybe hi and just introduce yourself for a minute?
Oh, hi guys. I'm Pedro. I'm from Brazil, and I am a Google developer expert in cloud AI. So happy to join share today with all of you.
Awesome. Thank you so much for taking the time to join us, Pedro. Karthik, oh no, you're unable to start your video. Do you want to say something? Can you go off mute?
Sure. Hey, everybody, Karthik this side. So happy to be joining here. I'm based out of New Jersey. I am one of the Google developer experts. So we'll be very happy to help you with anything and everything on Google Cloud and AI.
Awesome. Thank you so much, Pedro. William, would you like to say hi?
Hi, sure. Hi, everyone. I see this is a global event, so hope everyone's having a great conference. And I'm a GDE for Cloud and AI and happy to help.
Awesome. Thank you so much for taking the time to join us here today. And I'm going to share my screen just a quick sec. Can you see the slides now? Are you able to see that?
Yep.
Yeah. Okay. Yeah. I cannot see both. Okay. So today, we're gonna build multi-agent systems that are distributed. We're all gonna be doing that together. This is a hands-on session. I hope all of you got ready for that. And we have the three Google developer experts, William, Karthik, and Pedro, who volunteered to help moderate the chat question and provide you answers. So please ask your question to get help from our experts. We have only 45 minutes for this session, so we might not get through all of it. I will do my best to, keep a good speed, but also make sure people are with me. But just so you know, the lab we will go through today is available to you online to complete whenever you wish. So even if you don't get through all of it, this is still available to you. And if you want to learn more about this lab and get context and additional labs, feel free to navigate to these slides. These are not mandatory for this session at the moment. And by the way, I'm Shir Lador. I'm head of AI engineering at Google Cloud Developer Relations. Super excited to be here today. Super excited to see such a great turnout. And if some of you are also coming to Google Cloud Next in a couple of weeks, would be very happy to meet you there. I'm doing 2 sessions there, different sessions. So would love to see you. Come and say hi. So I don't know if you all saw this or not, but I sent you an email yesterday with a link to Google Cloud credits. Yes, you're actually getting money from us to use our services. And if you were able to see that or not, that's okay. I'm just going to quickly review the guidance on how to redeem those credits so you can follow along. You will need to use a personal Gmail account, a personal laptop, and the Chrome browser, and navigate to this link. You got it also in the email. It might be a little bit hard, so maybe one of the TAs can also paste it in the Q&A or something, so people get access to the link if they didn't see the email. Just go to the link, and then you have to follow a few really quick steps. You need to sign in to your Gmail account. You need to press the button to access the credits. Then you need to accept the terms and continue. Basically, we are giving you credit to a Google Cloud so you can start building without inserting any credit card information. This is $5 credit. It should be more than enough to complete the lab we'll go through today, and also additional labs that we will provide to you as additional resources. So after the credits are applied, you can go to Google Cloud and the billing page. Select this drop-down menu and make sure you create a new project. Or if you already created a new project, we want to make sure the billing is going through the credits we gave you. So how do we do that? This is how we create a new project. Basically, give it, whatever name that will be indicative for you. The billing account name would be something like this: Google Cloud Platform Trial Billing Account. So this should be available to you if you pressed on the link and redeem the credits, and then you can create this account. And if you're not sure if the project you created is attached to billing or not, you can just search for billing or go to the link here, click on My Projects tab, and make sure your project is associated with this new credit link, the Google Cloud Platform Trial Billing Account. So this is what you should be seeing. And I know I'm going through this really quickly. I also gave you the link to the slides with these kind of instructions and also a video. So you can take a look at that. And if you're having any challenges and have specific questions, please put them in the Q&A chat. And after you finish setting up your credits, open a Google Cloud Shell. This is basically a VM that we will start to run this workshop today on the cloud, so we can build our multi-agent system. So I know I went through all of this fast. Unfortunately, I cannot see how is everyone doing. I see there are already question in the Q&A. I see some people didn't get the email. So please, ask your questions. And we have a great team here to help us with answering them. Unfortunately, I cannot do both this session, but we have some great folks to help. Okay, so while you're figuring out the credits, hopefully some of you already finalized this process, I wanted to tell you a little bit about what we're going to build today, really briefly, just so you'll get the context. So everyone is building course creation system today. Everybody want to learn, and AI is a great way to do that. So today we're going to build our own course creation system. Education is a great place to apply AI to. We will use multiple agents to enable high quality and scalability for our courses. So how will we do that? Basically, we're going to use a few patterns in agents that will allow us to create very high quality content. One of them is the loop agent, which you can see here. We're going to have a researcher that is going to research information for our course, and a judge, and those two will talk between them. And only when the judge is happy with the researcher results, only then they will go back and send that information to the writer, who will draft the course for us. And what you are seeing here is basically the idea of separation of concern. Each agent has their own expertise, the thing they excel at. This makes it easier for us to debug our system and also to scale it independently. How we will build this system, as we said in the title of this lecture, is a distributed agentic system. So each of these agents will be deployed separately on their own Cloud Run instance, so they can scale independently and they will communicate with each other using A2A. So this is the loop agent pattern that we will create between the researcher and the agent. And those agents need to, in the end, run sequentially. After researcher and judge finish their loop, they will go to the writer. The writer would draft a blog, and the orchestrator would be used to keep the context across all of these agents. And as I mentioned, they will communicate using A2A, the agent-to-agent protocol, that allows them to talk through HTTP requests. Each agent will be represented by this kind of an agent card that has the name, the description, and the different skills that agent has. Yeah, so I don't want to waste a lot of time on the intro. Let's start building. These are the links you will need for today. Basically, the only link you need for the lab is the first one. I also added here 2 other links to other labs that we have that are the next sessions of this series that we will not go through today. And they will help you figure out how to bring your agents to production. So how to evaluate the quality of your agents, how to secure them. But today we're gonna focus on the first one, which is building your multi-agent system. So please navigate to this link, and I will now stop sharing my screen and will navigate to another window where I open this. Okay. Is everyone able to see my new screen? Not able to see it.
Yep, we can.
Okay, so I see someone asked, it's not PARI, it's PRAI. It's Production Ready AI. That is the right link. Okay, so let me just go through that link. Okay, so this is the lab we're going to get through today. And if you haven't already, you can start the Google Cloud Shell by pressing this little button here that you will see if you start Google Cloud Console. I'll show you how I'll do that. Just open the Google Cloud Console, go to my console. You're seeing this window now, right? And then please let me know if not, because I cannot see you when I'm sharing. Activating Google Cloud Shell, and then you should see something like this. You see I'm working on this new project that I created for this event. With this, if I want to make sure I'm on the right billing account, I just can go to billing and see my different projects. Maybe I'll just go and do that just to make sure everyone has this. And then I can see manage billing accounts. And you see I have multiple of those. And in the project, I can see Data Science Dojo. This is the project ID that we will need in a minute. So you can just copy this one. It also appears if you just select all your projects. And I can see that I'm on the right billing account. Okay, so, and you can see all the different events that I've been going through. So we will work on the same environment. I'm opening the editor. So this is like the most convenient way for me to work on the Google Cloud Shell. I'm opening this editor and you should see something like that. And then I will have a terminal window open. You may see the terminal window open here below the screen, but I actually like to work like this, where I have the new terminal here, and I move it to a move terminal into the editor area. So I highly recommend to have a few windows like this open. And in each window you open, make sure you are setting the project correctly. So in our case, you have your own project ID. In my case, I just copy pasted the project name. So you see, I didn't say it correctly. Gcloud config set project. Okay, so how do you know that you set your project correctly? You can see I updated property project here, and then you have your project set, your project name here, your project ID. So this is how I know this tab is currently on the right project. Now, this is very important because if you go to this, we will skip the introduction because we already did the introduction. We will go directly to the setup stage. So in the setup stage, the first very important step is to clone the starter repository to your home directory. Okay, so I'm going back to my home directory that is here and copy pasting this work. So what this does is just cloning the starter code for us, and you can take a look at what do we have here. We are now in the folder Production Ready AI Roadshow Lab 1 Starter. And you can see there are different agents here and an application that is the front end that we pre-built for this, and the PyProject 2ML that defines our dependencies, and different scripts to run it locally. Then in Google Cloud, we need to enable the different APIs that we are going to use. So for example, run is Google Cloud Run, on which we will deploy our services on. This is like switches to turn off those different services that we will use. We will use the artifact registry to store the container image that we will deploy on Cloud Run, the cloud build to build the code, AI platform for Gemini, and compute. So just copy paste this by pressing the copy code sample and enable all the different APIs. Now, for this step to work, you need to make sure your project is set correctly. You see, this is finished successfully. But if this didn't work, then it means you did not set your project like I did. So I remind you the command to set the project is gcloud config set project. Yes, is there a question?
Yeah, quick check. If you can zoom in your screen a little bit, that would be helpful for the participants.
Oh, yes, yes, yes. Thank you so much. Yeah, and keep on that helpful feedback, because I cannot see what you're seeing. So this is extremely helpful. Just go back to the right.
The terminal?
Yeah, do you see the terminal?
Yeah. Oh,
Is this
perfect.
better?
Yeah, this is better. Much better. Thanks.
Yes, I always forget that step. Like I always get that question and forget it. Thank you. Okay, yeah, so just make sure you set your project correctly with this command. Okay. And after we enable the APIs, we will install the dependencies with UV sync command. UV is basically sorry, why do I have this? UV is basically a command to install all the dependency. UV is a package dependency manager, which is extremely, extremely fast. If you use pip before, you will notice that this goes a lot faster. And instead of requirements text, we were using it pip. Here we use the pipe 2ML, a PyProject 2ML that we saw before. That's it. Everything is now installed for us. Another important step is to set up your environment variables. So we will create a .env file so we can store our environment variables, and just if we need to, if for some reason the session disconnects, we can just easily import those into the environment using source.env. So this command, just copy paste it, and it will create the .env file for us with the definition of the cloud project we are using, the location in the world where our servers are available, and the setting the Gen AI using Vertex AI. So different flags we need. And just to make sure this worked, I'm gonna vi.env. Just look at what we got. This is what we got at .env. So this would be with your specific project ID. And now we will source those environment variables. And again, if for some reason your session disconnects, you will need to reset your project like we did before and source the environment variables. Okay, now we're going to start building. So you can skip this step if you are already in the editor like we just did. If you're only in the shell and don't have the editor open, you can do this, Cloud Shell Workspace. And then we are going to start writing our code. So if you look at the Explorer here on your left, you can open your Accelerate AI lab starter. Sorry, this is not the right one. Okay, we can just do it from the path. I will just reopen this. Sometimes this happens. Okay. So you will see here, this is what we just git clone. And here we will find the folder named agents. In the agents, we have the 4 agents we just discussed. So if you can see here, my project was just not set anymore. So I will just reset it. And this will be a good demonstration for you that sometimes this happens and you just have to reset your project. So I'm again copying my project ID, just making sure I have everything. And I will also source the environment variables. This is in the PR, in this folder, the .env file, and I'm just sourcing it. Okay. So now I have all of my agents, and I want to start with editing my researcher agent. The researcher, all it does in this framework is to perform research for our course. For example, I would want to do a course about, let's say, personal strength training. So I can ask that the system, and the researcher will go research that using the tool we would provide to him. In this application, we just chose very simple tools, which is the Google search. And you can see here the instruction we are given to this agent. You are an expert researcher. You use this tool, summarize your finding. And then if you receive feedback that your research is insufficient, use the feedback to refine your next search. So this is the loop we talked about with the researcher and the judge, and we will soon implement that. So let's copy paste the code of the researcher definition, delete this to-do part, and paste this code right here. And if you have any questions about the code or anything is not clear, please drop it in the Q&A. Okay, so we edited the researcher and we saw how to define a Google search tool. This is a built-in tool with ADK, so we just need to write the name and import it from ADK, as you can see here. Very, very simple. Now we're going to the judge agent. The judge agent sits under the judge agent folder. So we can now copy paste this part of the code and go paste it there where the to-do is. And what is in this code actually? We can see that the judge has a specific structured schema defined using a Pydantic, which is how it returns the feedback to the researcher. So this is how it's implemented. We defined a class of how this schema would look like. Basically, it's a dictionary with a pass or fail and the description of why the research was declined or approved to give it as a feedback back to the researcher. And then the agent itself, and you can see the output schema is defined here in this field. And this is the instruction for the agent. And as you can see, there are these 2 flags here that basically say it forced the judge to only return the structured feedback. It cannot start chatting with the user or delegate to other agent. It's a very restricted agent in this case. So after we understood the code for the judge, let's go to the judge folder, open the agent py file, and remove these 2 to-dos for the judge feedback and the judge agent definition, and copy paste here the judge feedback and the agent. So this is our judge. Now there's an option here to run our tests locally and test each of them in isolation to see how they perform. So let's do this. We will copy paste this command, uv run adk run agents researcher. We will go back to our terminal here and we will run this. Let's see what happened. So this is supposed to basically run the researcher agent locally on this VM, not deploying it to anywhere, and then we can just converse with it and have it provide research for us. Okay, running Agent Researcher. So let's see, we want to ask it to find the population of Tokyo in 2020. Let's see what it will come up with. Okay, so it has a pretty nice response. We see approximately 40 million people. It also gives a little bit about the distribution, the diversity of the population, and the growth rate. Pretty elaborate, and you can of course test it with your own questions. Okay, so this is how we are testing each of the agents locally. And now the next step here, this is just a reminder in case your environment variables are not set correctly. If something is not working, maybe you need to set your project and re-export your environment variables. You can also do this by the source.env command we saw before. Okay, now in the same manner we are running the researcher, we can also run the judge locally. So we can just exit by doing Control-C, aborted, and then I will just run the judge locally just to see how the judge is performing. Now, to remind you, the judge is our judge of quality of research. So the type of responses it would expect are result of a research, and the judge is supposed to give us feedback. So for example, we could give it something like, oh, the topic of our research is Tokyo, and the findings are Tokyo is a city. So what do you think? Would that be enough information to provide from a researcher about Tokyo? Well, I don't know what you think, but the judge think this is failing. And the feedback is that it is insufficient because we want to give a lot more information if we're doing a course about Japan. We want to know about the population and its significance and any mentions of landmark, culture, or history. Okay, so now after we've seen how each of these agents operate individually, we will continue to build the content builder agent. So again, here is the code we're gonna paste for the content builder. This is a pretty straightforward agent. It uses the research finding from the research and judge loop that we will soon show how to implement. And transform that into a structured course. So with a main title, with sections, with bullet points, with the professional but engaging tone. And I want to challenge you all later when you're reviewing this lab at home, you can take this content builder and make it a lot more robust. For example, you can give it access to tools like image generation to provide illustrations for your course. Or maybe add a tool to create quizzes based on the information and create a quiz for the course. So you can just, be creative and expand the capabilities of this content builder. Same thing about the judge that we just saw. So the logic for the judge was pretty straightforward. If I would write a judge which is more comprehensive, I will actually, go back and proof check all of the content, and run some tests to make sure that the content is actually with high quality. So this is a very basic implementation for this one, but you are definitely able to just go and change the code and experiment afterwards. So let's go and build that content builder agent. It will be here in the folder for the content builder, agent py. And then you can see here that this is the code, and we just ran through it. It's very, very simple. It doesn't have any tool. It's basically an LLM task. It gets the context from the research finding. We will soon see how the context is managed with the orchestrator agent that we will define. And it's just using basic LLM capabilities. to write the course. Okay, so as I mentioned, the context will be passed through the session state, and now we will see how is that done. So the last part is the orchestrator. So in the orchestrator, which is here in the under agent orchestrator agent PY, we will start by defining the connections to the remote agents. So remember, I mentioned to you all, the agents will be talking between them using the A2A protocol, the agent-to-agent protocol. And this conversation is going to happen through HTTP request, and each agent is going to have their own agent card. So you can see here how that actually comes into play. Each agent has their URL defined. Remote A2A agent, this is how A2A agent are defined. Each of them has their URL defined, and we will get that URL right after we will deploy those agents to Cloud Run soon. We will have the description of that agent, and then remember when I mentioned that we're going to save all the research findings into the context. So this is where we're basically doing that. The researcher, right after it completes the operation, it will have this callback, which is a function that runs deterministically after the LLM finishes its work, to save the content, the research findings into research finding key in the state. And then you basically define here how the HTTP requests are going to be authenticated through this URL. So let's just copy paste this code and go to a orchestrator agent PY. So orchestrator is right here. Okay, and here in the orchestrator code, you can see the first function which is defined is the create save output callback. So this function is the one that saves the context from this agent operation to the shared state of all the agents. This is how the agents will communicate with each other. And then we have this to do to define connections to the remote agents. So here we will paste the code we just copied with the different A2A definitions of our 3 agents. And now we're going to continue with the orchestrator definition. So remember, I told you that we have a researcher and a judge that operate in a loop, right? The researcher runs research, and the judge that research, and then they both are stuck in a loop until the criteria is met for the quality of the research. So for that, we are adding this escalation checker. This is basically a component that helps us pass the feedback from the judge to break the loop of those 2 agents. And if the feedback from the judge, we saw that structured output, if the feedback is passed, then we break the loop. It means we met the quality bar and we can continue to the next step, which is the content drafting. So let's copy paste this code and move it here into the to do with define escalation checker. And by the way, if at any point you are not sure, you're always welcome to ask us question, but you are also welcome to open another tab. Let's see if I have an open tab here that I can use like we did before, and ask Gemini for help. The best way to do that would be to navigate to the folder that you're working in. For us is the PR AI Roadshow. And then you can just write Gemini, enter. And guess what? This would start Gemini CLI right there in your terminal. And that would operate with all the context of your code. So you can ask it, for example, is there any missing code in the orchestrator agent? I don't know what it will answer. I'm just improvising. Let's see what it will say. And then, as you can see, it has access to the different agents, to the different code in your local directory, and it could just read the code and give you an analysis. Okay, and it's saying, I will read this code to see if there are any obvious gap or to-dos. Okay, and while we're doing that, we can go back. We'll let it, oh, okay, it already returned. I identified 2 to-do sections in the agent PY that needs to be implemented, the research loop and the root agent. Okay, so let's go back to that code and implement it. Okay, I will stop it running. And of course, it will ask me questions before making any code changes, but basically it could write the code for me. So just a helpful tip for you all, if you're getting into errors you're not sure or want help with your with writing your code, this is a great tool, Gemini CLI. Okay, so now let's go and define our research loop. We are using ADK pattern called loop agent. Very, very simple. We're going to copy this. And as you can see, it just runs the researcher, the judge, and the escalation checker in a loop, one after another. And we set the max iteration to 3 because we don't want it to take too long. And you can see in the import, loop agent is just imported here from the Google ADK, which is, by the way, I didn't mention it, Google ADK Agent Development Kit is an open source framework to help you build agents. And it's really helpful. As you can see, the code is straightforward, basically like writing any Python code, not super complex. And the last step in the code is to define the root agent. For this, we will need the sequential agent pattern because we have a sequential process here. The research loop is running, and after that is finished, we need to go through the content builder. So the sequential agent is special because it is a deterministic flow. There's no model running here, it just defines that this loop needs to run first, and then this agent needs to run after. Okay, so let's copy paste that research loop into that sequential agent and define the root agent. This is basically the first agent that runs, and this is the one that connects to our front end. Okay, now we have all the code built in. The next step would be to test it locally. So for that, we have a script ready-made for you all. And remember, when you run this script, you need to be from the right project. Like we see here, this is my project, and you need to make sure all of your environment variables are set. So I can always do this by running source.env. And then I'm just going to run this script, the run local sh. This script will just start running all of my agents locally. You can take a look at the code afterwards. And basically make all of them available to chat with individually as well as through the UI. And I will not run through all of this tests at the moment, but you should do it later if you like. But you can just test each of those agents in isolation. So just run those curl commands. This one will give you the agent card for each of the agents. Each of them runs on a different local URL. This is for the researcher. And then you can also prompt them with different queries, as you can see here. And you can also look at the web preview of that local agent. If you want to do that, you can use the web preview button and change the port to 8000. So I'm gonna, you see there, this is the web preview button right here next to the open terminal button. And the default here is 8080. So I'm gonna change the port to 8,000. And then this preview my agent. This is how the agent look like with the front end. And I want to learn about strength training for women. And this is basically starting to run each of our agents locally, the researcher, the judge, and the content builder. So we'll give it a minute or two to run the research, and we'll come back to see what it came up with. And while we do that, we will continue to the next step, and basically the final step, which is deploying each of our sub-agent to Cloud Run. Remember, we said we are building a distributed multi-agent system. That means that each of our agents run independently and can scale independently according to the workload. So for that, because we have a few agents, if you want to do it in parallel, we can start a few different tabs and run each of the commands in one tab. So when we do that, we need to make sure we are in the right folder and that we are sourcing the environment variables, and also that we are setting the right project. Okay, this is still running. Just wanted to check. Okay, let's start with deploying the first agent. So I will start this new tab. And as you can see, my project is not set. So I will set it up. And by running gcloud config set project, and I'm going to go back and get my project ID because I don't remember anything by heart. Okay, this is my project ID. And now I will make sure that I'm in the right folder and source the environment variables so everything would work. And then let's start deploying the researcher. This is our Cloud Run deploy command. And while I run it, I will basically explain it to you. It basically says gcloud run deploy researcher. It's telling the Cloud Run where is the code. We are deploying from source here. So Cloud Run is building the code for us, creating the image, storing it in the artifact registry, and then running it on a Cloud Run instance for us. This is the region of the servers that we will use. In this case, we are using allow unauthenticated. This is not a secured way to run those servers, but we have a whole lab about security. This is just now for our experiment, but I really recommend you to check out our security lab later. This is just a label for us to know that you were able to do this, to run through this deployment command. And we're setting some of the environment variables here in the deployment command. So this should take a few minutes. And while it's running, let's see, ooh, my course is ready. So you can see this is our personal strength training course for women. Very nice. It has different modules, each of them explaining different things like transformative power of strength training, foundations of solid strength program, nutrition, training plan. So, oh, that's really cool. I'm going to copy paste this and use it in my next training. Very nice. Yeah, and injury prevention. That's very important. Okay, so now let's go and try and deploy our next agent. Oh, see, our first agent is already ready. That's cool. So we can use the same tab now to deploy our judge agent. And while we do that, we can also open another tab. I will just kill my local run of the agent because we saw that it's working. I can just use this tab again, and I will deploy the third agent, the content builder agent. And yes, we can do this in parallel. There's no issue with that. So content builder is getting deployed, and the researcher and the judge is getting deployed, and the researcher is already deployed. After all three of them are deployed, we're going to run this command, to capture the different URLs. Why do we need that? Because the orchestrator, we cannot run it before we have the agent URL. You remember when we defined the code for the orchestrator? I'll go back to that. We had this part where we defined the connection to the remote agents. So for each of them, we got the URL, and then we defined that agent for the orchestrator. So now after those agents are deployed, we can create an environment variable with the specific URL and deploy the orchestrator with that information. Okay, so now, oh, I have an error. That's great. Okay, let's see what's happening here. Why is the deployment failed? So let's see here, would this work? Probably I have some issue with my code. You know, the easiest way to do this is just by running Gemini. So I will ask Gemini what seems to be the issue. Maybe I did it too fast, I skipped a step. But Gemini would be able to tell me that because it has access to all of my code. So I'm just going to ask Gemini, why did I get this error? Let's see what it will say. And while it's doing that, maybe I will also look at the code and see maybe I made some typo here. If someone has any idea, that would be great. These are the best learning parts. So just a recap of where we are. We deployed the 3 agents. One had an error, so we're going to debug that now. And once those 3 are available, we can deploy the researcher with providing them, we can deploy the orchestrator with the different agents URL. And after the orchestrator is deployed, we can deploy the front end with giving it the orchestrator URL, because this is how it communicates with our multi-agent system. So let's see, why am I getting this error? Maybe, you know what, it is possible that it is a momentarily thing and I can just redeploy it. So that's also something else we could check. Let's see, we can just redeploy the judge. But you actually get to observe how I debug those issues using Gemini. And I will try and just redeploy it here on the other tab, see if there's anything maybe it was a momentarily. Oh, and one more thing you could check out. When you're in the Google Cloud Console, you can always search for Cloud Run and see all the different services that are deployed at the moment on Cloud Run. So as you can see, the researcher and the content builder are already deployed. You can also see the URL from here. And you can see, you can get logs for the different services and metrics. And also, you know, the different errors. Like if we will hit this server now, we will see it in the logs. Okay, let's see. I'm trying to redeploy the judge now. Let's see if there's, I think Gemini is still trying to figure out if there's any typos in my code. What could be causing this failure? Okay, I think we covered most of it. Are there, GDs, you've been monitoring the chat. Are there any questions you want to highlight while we're waiting to see if this will get deployed? Oh, okay. I went back to the judge and now it is deployed. So it was a momentarily thing. So we can just go back and capture the URLs. This is almost the last step. just capture the URLs and deploy the orchestrator agent. So these are the different URLs. And now we are deploying the orchestrator. And we just have 1 minute left for this session. I don't want to take from the next one. So I would just mention that after deploying the orchestrator, we will capture that URL and deploy the front end. And then we can just open it, the URL of the front end, and we will get it in the response and just play around with the agent. And it would look basically the same as what we've seen with the local run. And to summarize what we've accomplished, so we took a very complex task of building a course creation system. And instead of building it with just one huge prompt, we split the work into different specialized roles that allow us to maintain very high quality of the output. We maintain that quality control using the loop agent and a structured judge. And we build it for production by using A2A and independent scaling on Cloud Run. We use these two patterns, sequential agent and loop agent. And for the next steps, you can make your agents a lot more sophisticated. You can give them further tool. You can add to the researcher additional sources for research. You can improve the judge and add more specific criteria for judging or even human in the loop step. And you can also try different models. You can also create much better courses, like I mentioned before. I hope you were able to follow and that you all feel ready now to build complex, reliable agentic workflows on Google Cloud. And thank you so much for joining us today. I hope this was valuable for you. Thank you, everyone. And thank you to our GDs.
Thank you, Cher and team, William, Pedro, and Karthik. Do you want to take any questions? We have another 9-ish minutes, and if you want,
we have a few more minutes? Oh, yeah.
I mean, maybe 1 to 2 minutes. Yeah, you can take if you want to address questions, because I see a lot of questions. Please go for it.
Wow,
right? So,
a lot of questions.
yes.
Oh, yeah. How do we get our questions answered after this session? That's a great question. Actually, you can just, connect with me over LinkedIn. My name at LinkedIn is, exactly the same, Shirmir Lador. So just send me a friend request. Feel free to send me questions. If the GDs are also interested to connect with you all, GDs, please feel free to add your details in the chat. So super happy to connect with you all later. And I see a lot of positive comments. Thank you so much. Actually have to clear the room. I'm in the office. Someone is knocking. But
Okay,
thank you so much for
good.
your time. Yeah, thank you for joining. Yeah.
Thanks. Yeah. We will be back at 2:10 p.m. with our next session.
Thank you.
Thank you. Hi, Paige. We will be starting in about 5 minutes. We are on a break. We just wrapped up another Google tutorial. So yeah, so we'll be back in about 5 minutes. I mean, I will come back at 2:09.
Excellent. Cool. Sounds good. I'll go off camera and we'll see you in about 6 minutes. Yep.
Okay, great.
Cool.
Okay. Hey, Paige, welcome back. Looking forward to your tutorial. Last time I loved your tutorial, so let's see what you have up your sleeve this time.
Excellent. Let's do it. And I know that there are sometimes some issues with audio sharing via Zoom, so there might be some times during the presentation where I have to go personally on mute in order to share system audio.
Sure.
But I will let y'all know before that happens. So hopefully everything will work out okay. But I'm going to go
Okay.
ahead and start presenting my screen real quick.
Great.
Hopefully
So
everybody can see it.
I can see it. I will be here. I will be off camera. So if you need me, just let me know. I will be listening.
Cool. Excellent. And if you see any questions that look like burning questions that people need answers to, or that would be good to answer during the flow of the presentation, please feel free to share them. And I will try to be monitoring the chat as well. So if people have questions throughout the duration of the presentation, please do ask. If you have the question, I guarantee you that somebody else has it too. So hopefully we can get a lot of good questions answered.
Yeah.
So greetings, everyone. Yep. Greetings, everyone. My name is Paige. I'm the Eng lead for our DevRel team at Google DeepMind. I've been doing machine learning for a really long time. And there has never been a more exciting time to be either a software engineer or a data scientist or a person who's just high agency and predisposed to building things. I'm really, really excited to show you what we've been cooking up at DeepMind over the course of the last 6 months. And even more recently. So with that, I'm going to go ahead and get started. I don't think it's a secret that Google has been a little bit busy over the course of the last little while. Even just in the last month and a half, we've had a ton of different model releases. This isn't even comprehensive. Things like Gemini 3.1 Flash Live for real-time interactions with the model, Gemini 3.1 Pro and Flash Lite, which are two respectively very large and very small models that can do a lot of really interesting multimodal tasks, especially agentic multimodal tasks. Nano Banana 2 for image generation and image and text interleaved, image editing. The Embeddings 2.0 model, which is really, really good at putting video and audio and images and text and code all in the same embedding space. So you could say, show me everything related to cats. And it will show you not only videos of cats, but also images, also like big books about cats, and then also the sound of a cat purring, which is pretty wild. Lyria 3 for music generation, including music with audio, which we'll see in a second. Genie 3 for world model building, which we'll also take a look at. Our full stack runtime for AI Studio, which incorporates things like databases and OAuth and a whole bunch of other things. Our Gemma 4 models, which are Apache 2 licensed. They come in a variety of sizes, and you can use them for things, everything from multimodal understanding to making tool calls locally and on device, and VO 3.1 Lite for video generation on a budget. So all of these things, all of these many, like very different sorts of things have been released over the course of the last month and a half. And this might be a little bit of a refresher from last year, but just want to keep underscoring Gemini is kind of special in the industry in the sense that it's uniquely multimodal. So it can understand video, it can understand images and audio and text and code and all of the above all at once. But it can also output multiple modalities. So it can output text, it can output images and text interleaved. It can output audio. It can output sequences of images that you can stitch together into a video. It can output code. And that's really, really special, given that most of the other models on the market are really, really kind of designed to only output text or code only. But it's a lot cooler to show things rather than just tell them. So I'm going to go ahead and share AI Studio. And this is my personal instance of AI Studio. So if folks see anything embarrassing, like please do not laugh, or you can laugh, just laugh silently. I also want to type in the chat the ways that you can access AI Studio. So you can go to ai.dev or ai.studio or aistudio.google.com. You can get started for free using just your Gmail account. And you can do everything from generating API keys. So if you open up this section on the left, you can generate API keys. I also just want to confirm that that everybody can still see my screen. Is that correct? I'm going to take silence as a yes. So hopefully everybody can still see my screen. You can create API keys. So if you just click Get API Key, you can see all of them for a given project. You can also see that I have a significant problem with generating API keys. You can create them off to the right just by clicking this button. And then you can also even monitor things like your usage, your total number of API requests, your rate limits, your overall spend, and the different models that you're using, your billing. And I've also turned on something called logs and data sets, which gives me insight into how people are using the models that I have deployed as part of the apps on my personal website, which we'll take a look at in a second as well. So if you've never experimented with AI Studio before, I'm going to show you a couple of tips and tricks, and then hopefully you'll be able to feel comfortable turning on all of the knobs and dials yourself, and learning how to experiment with more and more along the way. So as an example, I've selected over here on the right, Gemini 3.1 Flashlight Preview. This is one of our tiniest models. So you can see that the input cost per million tokens is around a quarter. So you can do a lot of really good work for just pennies on the dollar. And then the output is $1.50. You can also input audio at around 50 cents per million tokens. And then you can see some of the other models that we have available as well. But let's go with Gemini 3.1 Flashlight. I'm going to go ahead and add some sample media. So you can select a video via sample media. You can select a YouTube video and a YouTube URL. You can record audio. You can record camera footage. You can add files from Drive, including things like PDF documents or uploading files. And just to show it off, I'm going to find a YouTube video, and then we're going to analyze it in real time. So an example YouTube video that I really, really love is Alan Kay at the Computer History Museum. So this, the Dynabook, Past, Present, and Future. It's a long video, so around an hour and 50 minutes. We're going to see if we can even put this into the context window. I've never tried this before. So it looks like it does go into the context window. And I'm going to ask a question to the effect of segment this video into detailed chapters, and tell me every instance that Alan Kay references Xerox PARC, which was the place where he worked at the time. If none of y'all know, I am a massive Xerox PARC nerd and love reading everything about computer history. But what's happening behind the scenes right now is this very, 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 very long video, which is around almost 2 hours, is being bundled up, which is taking the majority of the time. It's being sent to the model for inference, and then it's going to be able to have kind of a segmentation of chapters and every instance where Alan Kay references Xerox PARC. You can also see that I've selected the media resolution to be the default, though you can select it to be low, medium, or high. Since I'm just asking for segmentation in chapters for like the audio contents, I probably could have gone with low, and we would have been able to move a little bit faster. You can select the thinking levels to be a little bit different, so minimum or minimal, low, medium, or high. And then you can also see the chapters getting referenced, the Xerox PARC references, so the lessons of PARC, creative environment at PARC, far out research, etc. And then if I click get code, I have all of the code that I would need to replicate what I just did in the UI. So you can see the chapters, you can see kind of the prompt that I had shared with the model, the YouTube URL, the model that we had selected in Python and TypeScript or in whatever your favorite language might be. And then even more importantly, if I hover over this token count and I zoom in, you can see that to analyze this 2-hour almost long video was just around 33 cents, 34 cents almost, which is wild. Like, and you could have asked for anything. You could have asked for a transcription. You could have asked for, all of the logos that were present within the video. You could have asked for all of the speakers within the video, like timestamps for different events or different occurrences, whole bunch of stuff. And it ended up being around, far less than the price of a cup of coffee, which is pretty wild. So these are some of the things that you can do within AI Studio. You can also just kind of speak and have things transcribed. So as an example, I could, hi, my name is Paige Bailey. I'm currently presenting at an Agentic AI conference online, and I'm going to start speaking in a different language. Wer reitet so spät durch Nacht und Wind? Es ist der Vater mit seinem Kind. Hat den Knaben wohl in den Arm, hält ihn sicher, hält ihn warm. Then I'm going to stop that. And so that kind of does the transcription not using the Gemini models, but I could also record audio. So let's try this again. Hi, my name is Paige Bailey. I'm currently presenting at the Agentic AI Conference, and I'm going to speak in a different language. Wer reitet so spät durch Nacht und Wind? Es ist der Vater mit seinem Kind. Hat den Knaben wohl in den Arm, hält ihn sicher, hält ihn warm. Add it to the prompt, and then say something like transcribe in a table with timestamps, all of the audio that you hear in this snippet. If a non-English language is being spoken, transcribe it and translate it. And then again, maybe make the thinking level high, and hit run. And so this is around 638 tokens. And it tells me who rides so late through the night in the wind. This is, and this is correct. So speaker, timestamps, transcriptions, etc., which is quite cool. We also have a new feature within AI Studio called Build, which allows you to create apps just by describing describing it to Gemini, or you can remix apps that we have in our gallery. So as an example, we just recently added support for database and auth. So you can build apps with custom databases. I'm going to go ahead and go to the gallery though, and see one of the apps that we have related to Lyria. Lyria is a music generation model that creates not just music, but also audio or also lyrics in any number of languages. So I am going to ask folks in the chat, does anybody speak a language other than English? I'm going to need somebody to fact check the song that we create.
So Paige, I can get by with Arabic. I'm a native in Urdu, which is very much like Hindi, so I can get Hindi and Urdu both. I
Oh.
see Natalie has French and Italian. So
Excellent.
yeah, I mean,
Let's do Urdu, and then you can tell me if the app does a good job of generating a music track.
okay.
Yep, cool. So behind the scenes, this is using Lyria. If we inspect the code for the app, you can see that in the Gen AI service, it has kind of the different models that it's calling, the API key, and the different model names. And then if we go back to the preview, I'm going to say something like electronic, danceable, um, all about the trials and tribulations of linear algebra and ASI, lyrics in Urdu. And then I'm going to generate the song. We should see it synthesizing. I'm going to go ahead and share the window, so you won't be able to hear me, but hopefully you'll be able to hear the track.
वेक्टर की दुनिया मसले हजार मैट्रिक्स के जाल में उलझा है प्यार आइजन वैल्यू एजेंट वेक्टर मुश्किल ये सफर एएसआई की मंजिल क्या होगी खबर ये मुश्किल इक्वेशन ये उलझी सी बात डांस फ्लोर पे आजा बस झूम ले साथ डांस फ्लोर पे आजा बस झूम ले साथ
This is hilarious. This is hilarious, right? For those who speak Hindi, they should be able to get this. This is amazing, right? So
Awesome.
maybe I have a second business lined up, right? So if I don't succeed in data science, maybe I can disrupt the music industry.
I'm telling you, like I've been using it to create music tracks for my little cousins about different concepts, and they absolutely love it. So like you can also one of the things about the mode that this Lyria Studio example app has is that you can also do karaoke mode. So Gemini will hear you singing along with the song, and will automatically kind of show you the lyrics along the way. But it's really wild to see. It's really wild to see the kinds of things that you can create, and also the how powerful Lyria is as a model. And so one of the things that you can do is you can remix apps. You can kind of create your own apps. And so I'm going to go back to build. I'm going to describe an app that I would like to have created, not using Lyria this time, like just an example app. I really want a database and auth. And for this app, I want create an app that takes in an image of a bookshelf. So you can see spines of books on the shelf. I want you to use Google search to enrich the data. So I want things like author name, title of the book, description of the book, and I want it all to be stored in a database. I also want to be able to log in with Google Auth. So when I log in with Google Auth, I'm able to save my own personal bookshelf. And the app should take in this image and populate all of the books in a database, which was not the clearest explanation. But you can see the spine of the top, personal database, log in with Google Auth, etc. And we're just going to click build. I'm also going to select Gemini 3 Flash Preview, which is the default. And this should kind of immediately go to work kind of creating this app. It'll take a little bit because we're going to be setting up a Firebase database. We're going to be doing a whole bunch of additional background infrastructure and plumbing. So I'll probably do a couple more demos while this is cooking. But if you haven't taken a look at AI Studio recently, I strongly suggest that you do for build. You can select different models to use. you can take a look through different versions. So as you create different implementations or edit implementations of apps, you can see them listed here. You can add secrets. So you can add secrets not just for the Gemini API key, but if you have like a Supabase API key or an Anthropic API key or any others, you can kind of stitch them together. If you just wanted to create kind of like cron job services, like you could create them through AI Studio as well. You can create integrations, so things like enabling OAuth, and you can also link to GitHub to either public or private repos. And then as the model kind of creates different files, it'll add them into the directory. You can also add files. So just adding files from Drive or uploading files, or sort of taking a picture with your camera and adding it to the prompt. But it looks like this will be working for a little bit, and it's in the business of setting up Firebase right now to do my app. So let's leave this running in the background. And while it is, I'm going to go ahead and pop over to Genie, which is a project within DeepMind that allows you to create and share a world. Like, what does this mean? This means that you can describe a scene, you can describe a character, and then you can dynamically interact with that world using the character, the same as you might with a character in a video game. And so as an example, if I was to type in, maybe the world looks like, I think everybody has their mind on the moon right now, or hopefully everybody does. You know, humans are the furthest away that they've ever been, and are taking like all sorts of wonderful pictures to share back with the rest of humanity. So maybe the world looks like a lunar surface, and some of the pictures that were colorized just recently made it look like a rainbow. So lunar surface with a rainbow sheen, and sparkles, with robots roving around it, and then maybe the character is something that you would not expect to see on the moon. Maybe it is a purple and pink dinosaur wearing a bicycle, or let's make it fun, riding a bicycle. And create a sketch. And so what's happening behind the scenes is that there's this model harness getting deployed of a combination of Nano Banana, of VO, and it's using Gemini behind the scenes to kind of create this world environment. And as it does, it will be generating frame by frame every single interaction that we have within the world. So it looks like we've got our first implementation. So let's create the world. And there's no physics engine behind the scenes. It's just the WASD keys to move around the dinosaur, the space bar to make it jump, and then the arrow keys to change the perspective of the camera along the way. So this is all kind of an agent harness set up to kind of sort of see the world itself. And so we've got our dinosaur riding a bicycle, like multiple dinosaurs. We've got Mars rovers, which is pretty cool. If I jump, you can see the dinosaur jump. You can see it nudge the rovers out of the way as it moves towards them. You can see the change in perspective, and it looks like it is riding a bicycle. It's just we didn't quite see it off to the side, and maybe it's more of a unicycle. No, it looks like a bicycle based on the shadow, which is pretty cool. And then it can maneuver closer and closer towards the lunar base. And again, this is just pixel by pixel, getting generated dynamically. As I move the little arrow keys, you can kind of see the new features come into action. the dinosaur doing the jumps with the space bar, and then how it interacts with the environment. So like if I had it walk towards that crater, it would probably fall in the crater, which is pretty wild. But this is Genie 3. It's currently available through Google's kind of ultra plan for AI services. And then hopefully the team is thinking about creating an API longer term. So that might be something that would be worthwhile for folks to take a look at. I think it's really remarkable to see kind of the breadth and the spectrum of things that these models can do within the context of being able to stitch things together, as opposed to just relying on one model to do all of the work. And that's kind of the promise of agentic development, is being able to couple together a lot of these processes that can work asynchronously. I'm going to show you another example of Gemini models in action, and then we'll take a look again at one of the app that we had been generating in the other window. But I'm going to share this tab. I'm going to go ahead and turn on Google search grounding, which is here at the bottom. This model is called Gemini 3.1 Flash Live Preview. We are not the best at naming things, but it basically gives you the ability to have a conversation with the model about anything that it sees. So as an example, I could share my screen, and hopefully folks will be able to hear this. If you can't, please let me know. Hey there, Gemini, can you tell me what you see on the screen?
I see a web page with a psychedelic scene inside a bubble. There's a purple dinosaur riding a bicycle, a rainbow puddle, and what looks like a moon landing vehicle in the background. Below the bubble, it says, "Thanks for exploring," and there's a button to create a new world. Did you make this image?
Mm-hmm. And so could everybody hear that? Hopefully.
Yes, we can, Paige.
Awesome. Excellent. And then you can also dynamically swap. So you could say something. I believe you mentioned that folks on the call, or at least a couple of folks, might be able to understand Hindi. Could you please tell me again, but could you tell me in Hindi? And then also please tell me what the weather is like today in London in Hindi.
जरूर। स्क्रीन पर आपको एक अजीब सी दुनिया दिख रही है, जैसे किसी बुलबुले के अंदर। इसमें एक बैंगनी रंग का डायनासोर है जो साइकिल चला रहा है, एक सतरंगी पोखर है और पीछे चांद पर उतरने वाला एक वाहन दिख रहा है। बुलबुले के नीचे लिखा है थैंक्स फॉर एक्सप्लोरिंग और एक बटन है जिस पर लिखा है क्रिएट अ न्यू वर्ल्ड। और लंदन के मौसम की बात करें तो आज वहाँ धूप रहने का अनुमान है और तापमान करीब 20 डिग्री सेल्सियस तक जा सकता है। क्या आप कुछ और जानना चाहते हैं?
And so it was able to incorporate what it knows about the London temperature and Google search suggestions to do the grounding. And then again, if I click Get Code, it gives me all of the code that I would need to use to replicate what we just did. So it selects the model, it has the appropriate configuration, it has the one-liner for Google search as a tool, and it also tells you how you might stitch together the pipeline. Which is pretty awesome. So that is Gemini Live. You can use custom functions. You can use some of our baked-in tools. You can change the media resolution. Right now, it samples at 1 frame per second, but and at 258 tokens per image for each one of those frames. But you can toggle it to be 66 tokens instead. You can change the thinking level, so from no thinking to low to medium to high, though that will change the model response times. And you can also select different voices as well. The cost for this ends up being about a penny a minute for audio only interactions. And it also, I heard a sound, which makes me think that the shelf scan is ready to go. So let me zoom over to the app that we had created. So it's asking for access to my camera. I'm going to allow it. Your physical library digitized in seconds. Wow. Get started for free. How it works. This actually looks very pretty, like prettier than I would be able to do. And then so get started for free. I'm going to select my personal account. So it's logged in as me, which is kind of awesome. It says scan my first shelf. I don't have a photo handy, but I bet you we can find one. So bookshelf with books and visible spines. Going to find it real quick. Like this looks like a reasonable one. Yeah, so I'm going to save image. Then go back to our app. I'm going to upload the photo. So it's scanning the shelf. It's identifying titles and fetching descriptions. And it's mentioned that it selected Gemini 3 Flash down here in the footer. So it should be pretty fast. And it found all of the books. It gave the appropriate date for when they were cataloged. And then, so Dead Reckoning, That Camden Summer, Unnatural Issue. Let's make sure that those are, yep. So I see Dead Reckoning, An Inconvenient Woman, The Piano Tuner, etc. And all of those just got added to my bookshelf. And then if I sign out and then sign back in, they are all still persisted, which is pretty wild and kind of awesome, right? Like, so, and if I was to share, this link, so I'm just going to copy the link and I'm going to put it in the chat. Like all of y'all would also be able to go to this app and upload pictures or take pictures of your bookshelves, sign in with Google and save them there. Which is amazing. Like being able to have that ability to create such a thing in a very, very short amount of time. That has the ability to catalog books. My next feature request would be like, give me the ability to check them out and to know who I check them out to, because my friends have a tendency to run away with my favorite books for a very good reason. But this is what you can do with AI Studio, and then you can also even click publish. And if you've attached your app to a cloud project, then your cloud project gives you a unique URL that you can kind of have deployed on Cloud Run and see your consumption and utilization that way as well. So that is AI Studio. And then in the last little piece, I want to walk through a little bit Gemini Nano, or not Gemini Nano, but Nano Banana. So I'm going to select Nano Banana 2, which is our latest image generation and image editing model. One of the things that I think is a little bit slept upon is that, so as an example, you can upload some of the sample media. You can change the sample media. I'm going to add this picture of a cat, maybe this picture of a dog. And you can also do things like reverse image search and grounding with Google search. So I'm going to do image search of a can of Celsius. So show the cat and the dog are sitting in the remnants of an AI hackathon in a school's computer lab. So maybe being a little bit less drastic, sitting in a school's computer lab with multiple cans of Celsius. And if you don't know what Celsius is, please count yourself lucky. But it is like a drink with a whole bunch of caffeine that is notorious among programmers for its kind of sort of energy giving and life force giving purposes. I think it tastes a little bit like battery acid, but I am one of few that feels this way. But we've got this cat, we've got this dog, and so we're asking Nano Banana 2 to create an image of them in a computer lab with a couple of cans of Celsius. We can see the dog and the cat with cans of Celsius around in a Python textbook with some lab PCs. And then if we wanted to, again, just kind of hover over the token consumption, you can see that the total cost of this model is really, really inexpensive, especially given that the original version of Nano Banana Pro was like 4 cents per image. So the costs have gone down pretty significantly. And again, if you click Get Code, it gives you all of the things that you would need in order to replicate what you just did within the UI. You can also change the different resolutions. You can change the aspect ratios. And then another one of the models that we've just released is VO 3.1 Lite. I'm not very good at creating video prompts, so I usually just get Gemini to create the video prompts for me. So with that, I'm going to have it, we're going to use Gemini 3.1 Flash. I'm going to say create a prompt that I can give to a video generation model to create stock footage for a horse ranch in Texas that also doubles as an artisan or like a vegan restaurant that is basketball themed in celebration of the Warriors. So we've got Gemini 3 Flash. Be concise with the prompt and keep it a single paragraph. I'm going to go ahead and click Run. And then we'll take the output that Gemini gives. So drone shot. And go back to VO 3.1 Lite, which is one of our, again, one of our latest models that gives you the ability to have movies of up to 8 seconds in duration. You can also make it kind of vertical, like a phone style. And I'm going to hit run. We'll see how well this goes. Cinematic drone shot of a sprawling Texas horse ranch at sunset. I'm going to get real homesick. You can also change the output resolution, though the default is 720p. We don't have 4K as an option for VO 3.1 Lite. Really, the intent is to use it as kind of a sketch so that you can get the idea of the app that you would like to create created cheaply and very, very quickly. So let's see how this goes. And it also has audio associated. So I'm going to, again, go on mute and share the audio for the other window. Studio itself. But I'm going to share my entire screen. And I'm going to show you Antigravity. And I'm going to show you our computer use capability, which is basically, I could say, go to ai.google.dev and create a comprehensive walkthrough with images and text interleaved, saved as a markdown file for a step-by-step guide for how to create an API key. I'm going to go ahead and click send. And what's going to happen behind the scenes is that it's going to recognize that it wants me to go to a website. It should launch a browser. So we're going to see if it launches the browser. There we go. And whenever you see the browser have a blue border around it, that means that the model is taking a snapshot and it's incorporating it into a guide. You can also see it click various things on the screen in order to help accomplish its tasks. This one I've selected Claude's like Opus 4.6. So it looks like it's taking a little bit of time to figure out where to go, but it's found my API keys. It's also signed in as me. So it has access to all of the things that I have access to. And it's generating screenshots along the way, so it will be able to have them stored as items in the markdown file. And I'm going to go ahead and delete this key. Delete, so that nobody can copy it. And then I'm also going to stop presenting real quick. There we go. And I will show you the walkthrough after it gets created. But it's taking screenshots and kind of doing text along the way. So the computer use capability in Antigravity, I feel like, is also something that is very slept upon. You can have it do everything from like, hey, please go look at the emails that I've received in the last 24 hours and draft a response to each one, to go and look at this website and create a spreadsheet for all of the items that you see in a table, to, hey, go on rei.com and find me like really cool pink hiking boots to wear. So it's wild to be able to see the things that it's capable of doing. And it also looks like it was able to create the walkthrough. So I'm not sure if y'all can see, but it's analyzing the screenshots. It's generating the intermediate steps. If you click on each one of these images, you can see the screenshots that were taken. And now it's creating the markdown file for the walkthrough. So let's see. I know usually I have like 7 or 8 agents running simultaneously, and so when one is working, I just move over to the next one to check in on it. But while this is cooking, I know we just have 5 minutes left. Does anybody have questions? I see some. I don't really have slides, so slides aren't quite going to be available. But here's the markdown file that was created. You can see the intermediate screenshots. And then the read the docs section and the summary of the full flow, as well as the different code samples along the way, which is pretty rad. So all of that created super quickly. And you can just kind of automatically generate documentation for your website as well, just by asking, which is quite cool.
Thank you so much, Paige. I think there are, if you have some time, we can take some questions.
Yeah, I do have 5 minutes, but I have a hard stop at 11.
Okay. Where are you based? Are you in Europe somewhere?
Oh, so I'm currently in the UK. I'm in London, but normally in San Francisco.
Okay, awesome. I think one of the questions that I had and someone else also asked when you generated the music, what about any copyright claims? Because at the end of the day, it is generating from some sounds that exist, right?
So the Lyria model was trained on permissively licensed data, so no copyrighted material, which means that you could say, do something in the style of, using generic terms, but you can't say
You cannot
something.
name an artist, right?
Exactly.
Okay.
Yeah.
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 Yeah. Okay. That sounds good. And there is AI Studio a monthly subscription? I think I know the answer, but maybe just
So AI Studio, you attach a credit card, so you can pay through your cloud project, and then there's not really a billing subscription. We also have a pretty generous free tier, or there's not like a subscription. It's mostly like paid by consumption.
Mm-hmm. And free tier replenishes every month, or is it?
It replenishes sometimes every day or every minute.
Mm-hmm.
So you have a certain amount of quota per day, and then it would refresh per day.
Okay, that sounds good. I think I do not see any other. Is Genie 3 available for us for public?
So you can, if you have a Google Ultra subscription, and you're in one of the locations where Genie 3 is available, then you can use Genie 3.
Okay, that sounds good. Let me see how much time. Maybe I will take one more question here. There is maybe we have a film project. Could we use Gemini to refine and enhance the storyline?
Definitely, yes. Yeah, we have quite a number of companies that are working on tools for filmmakers, and they're all using the Gemini models.
Okay, but I cannot upload like past Mission Impossible episodes and then have Tom Cruise running.
I think there's a disclaimer that any data that you analyze, you have to have permission to use.
Yeah. Sounds good. Thank you so much, Paige. As always, it was awesome. It was amazing having you.
Excellent.
Thank you so much. Have a
Thank
good
you
night.
for having us. You too.
Yeah. Thank you.
Bye.
Bye. Okay, so we will be closing the day. I hope you enjoyed the tutorials today. So tomorrow and the day after, maybe I will flash a few workshops on the screen just in case. That would be the agenda for the rest of the week. Let me just very quickly bring it up. Okay, here we go. So we have 6 workshops happening over the next 3 days, actually. So we have workshop on reinforcement learning by Luis Serrano. Then we have a workshop from Docker. Oleg is going to present. We have a workshop from Landing AI on OCR. We have another workshop on reinforcement learning and GRPO and related ideas. And then we have, if you want to build more intensive, intent-driven RAG applications, we have a workshop. Let me show you here. We have by Scott, all of these are actually amazing instructors that I respect a lot. I look up to them. They're great instructors. I mean, Luis, Scott, I have actually seen them. They are part of our boot camp as well when they teach. And then you attended a tutorial today by Samba Nova. And then we have this Agentic AI for Scalable Healthcare Intelligence with Samba Nova. If you're working in healthcare, of course, healthcare is a very interesting, highly regulated industry. So this should be very helpful for you guys to attend. And I am happy to answer any question. I will just take one look at any of if there are any questions. Otherwise, yeah, I think that should be it. Thank you so much, everyone. I hope you found it useful. If you receive any survey about the panels and the tutorials, please help us improve, help us understand, and please let us know if you think that any new topics should be incorporated. We will be doing another edition of this workshop. We try to do it about twice a year, so we will be doing it again in a few months. Thank you, everyone, and please reach out to us if we can be of any help in any way. Thanks, everyone.